Hello and welcome to the Academy. So in this video, we are going to see what is a Snowflake. Uh, so it's a full data warehouse built for cloud. Uh, their vision is that all their customer can access all their data in one place to make actionable decision anytime, anywhere with any number of user. It is also a next generation data warehouse built from ground up for the cloud to address today's data and analytical challenges. Now, three most important features of Snowflake is it's a complete SQL data warehouse. So anybody who knows SQL, they can work with Snowflake. The second feature is it's only built for cloud. So you need to have a cloud access to access your Snowflake account. The third one is that it delivers as a service to the end customer who is using a Snowflake so that you don't have to worry about the infrastructure setup uh, or management of your Snowflake account. Everything will be done by Snowflake itself. So these are the three most important feature of Snowflake. Now let's talk about where Snowflake is going to fit in terms of your data landscape. So first we are going to see the legacy data landscape, like how in the legacy world we were setting up the data pipeline to move the data from data sources to our enterprise data warehouses or data marts, and then on top of that we were doing BI or analytics work. So on the left hand side, if you see, you will have different data sources. Uh, these data sources either will generate structured data, or there could be some sources where the unstructured data are coming. Okay, so to move this data to our EDW layer, which is nothing but your enterprise data warehouse layer, you might have to use any ETL tool which is going to connect to these data sources, extract the data from there, transform it based on your business logic, and load it to your data warehouse. So these all sources are going to give you a structured data, and here for those structured data, we are using ETL tool to pull it to our enterprise data warehouse. Let's say we have a data sources where we are getting unstructured data such as web apps or IoT devices. So they will contain unstructured data. So for that, before moving it to enterprise data warehouse, we might have to store that into somewhere on the data lake. So here the data lake, we can use a data lake such as AWS S3 or Azure Blob Storage, or any kind of a Hadoop system where we can store these unstructured data and then move it to format this data from unstructured to structure and then move it to enterprise data warehouses. In terms of enterprise data warehouses, we could use technologies, tools like Oracle, SQL, Teradata, Postgres, and all that, where we can build our enterprise data warehouse. Now, once you have your EDW, which is enterprise data warehouse, you might have to create different data marts based on your different use cases. And these data marts will can be created on tools such as Oracle, SQL servers, or Teradata also. Okay. Once you have the data into enterprise data warehouse or data marts, you can use any BI or analytics tool to run reporting or machine learning algorithms either from your enterprise data warehouse or data marts or a data lake or Hadoop, from where you can do the machine learnings. So this is a typical legacy data landscape where what you have used multiple tools and technologies to build your end-to-end data pipelines. For an ETL, you might be using some tools such as Informatica, SSIS, and all. For enterprise data warehouse, you might have to use tools such as Oracle, SQL servers, or Teradata or Postgres. For data lake, or we might have to use AWS S3 or Azure Blobs containers, or any kind of a Hadoop systems. For data marts also, we might have to use some other tools to host our data marts. So if you see from data sources to BI analytics, we are using multiple tools and technologies, okay, to orchestrate our data pipeline. And if you are using multiple uh, tools and technologies, there is always a cost associated with that, and there could be a multiple failure points also over here. Now let's see how Snowflake is going to fit into this picture by replacing our legacy data landscape. So if you see this particular image where This is the modern data landscape with Snowflake in place. Okay, your data source is same, your BI analytics is same. If you focus on the middle layer, what we are saying that Snowflake is going to be used either your enterprise data warehouse or a data lake, or you can use Snowflake to build your data marts, and also it can work as an ELT tool. Okay, so in the previous video, previous slide, if you see, to build this, you have used multiple tools and technologies. But if you use a Snowflake, you might not have to use multiple things. Everything can be done inside the Snowflake itself. Okay, so that's how the Snowflake has changed the data landscape compared to your legacy systems. Okay, because everything is now under one umbrella, and if there is any issue, you only have to focus on your Snowflake account, and and then build all this based on different use cases inside the Snowflake itself. So this is how Snowflake is being used as part of your modern data landscape. Now let's see some of the features of your Snowflake account. So as we said, it's a data warehouse built for the cloud. Okay. So the first is it's a complete SQL database, right? If you have a prior experience in working with SQL, you should be confident about in working with Snowflake also. The structure is same, like you have a database, you have a schema, you have tables and views, all the different SQL statements work in Snowflake as it is what they used to work in the previous tools and technologies. It's a self-tuning platform, so you don't have to worry about making sure your query is optimized or not. If your query is also not up to a mark optimized, Snowflake will automatically optimize that query and run it on your behalf. Okay. The third is all your data. So in all your data, you can store any type of data which your organization have, right? Whether it's a structured, unstructured, semi-structured, coming from different data sources, all your data can be stored into your Snowflake account. The fourth one is all your user. So since all the data is stored at a single location in Snowflake, different users of that organization can access the same Snowflake account to perform different activities, right? So there could be a data exploration and team who want to access the data from a Snowflake. There are some teams who is doing ML operation. They can also access the data from the same Snowflake account. And there are some teams who is doing BI and reporting. They can also access the data from Snowflake and build their reports on top of that. So this is the fourth feature of a Snowflake. Now the fifth one is pay only what you use, right? So in Snowflake, it works on a credit-based system. So whatever queries you run, you only have to pay for that. There is nothing a hidden cost associated with Snowflake that okay you have to purchase this and you have to invest this much of credit for that. How much data you store into Snowflake and how many queries you run in Snowflake, it is only going to charge for those queries and that amount of data stored into Snowflake. The last one is it's a live data sharing. Since all your data is stored into one location, um, anybody who wants to access the data, as soon as the data updates in Snowflake, everybody will see the updated data. That means it's a live data. There's nothing that okay the tables has been refreshed but it is showing a different value to one team and a different value to another team. It's not like that, right? Because it's a single source of truth for everybody who is accessing the data in Snowflake, and that's why the last feature is it's a live data sharing. So this is an overview of Snowflake. Hello and welcome to the Academy. So in this video we are going to talk about different editions of Snowflake. So currently Snowflake provides 5 different edition based on your users or company's requirement. The first is the standard edition. So some of the features of standard edition is that it's a complete SQL data warehouse. Uh, it supports the business hour from Monday to Friday. You will have a, by default of 1 day of time travel in the standard edition. You cannot go beyond 1 day. Uh, it also supports a customer dedicated warehouse and also have a feature of database replications. So that is your standard edition. Uh, Another one is the premium edition. So in the premier edition, you will get whatever you are getting as part of the standard edition. Along with that, you will get a premium support 24 by 7 into 365 days. You will have a faster response time for any queries from Snowflake compared to your standard editions, and you will have SLA with a refund for any outages. So any outages happen into your account, you will have a refund from Snowflake. Now the next one is the enterprise version, where most of the companies uses this particular edition of Snowflake. So enterprise version will contains all the features what you have into standard plus premium editions. Along with that, you will get a multi-cluster warehouse support into the enterprise version. The time travel in enterprise version will be maximum of 90 days. So you can go up to 90 days as part of the time travel. You will have a feature of materialized view supported into the enterprise version. Also, it provides a AWS private link for extra fees for the enterprise version. So these are some of the features of enterprise version. Now, after the enterprise version, you will have two, which is specific to your own requirements, such as the first one is the business critical. So this contains all the features of the enterprise plus standard plus premier. Along with that, it also supports the HIPAA supports. And it is also a PSI compliant. So the data, if there is a data which is needs to be compliant for some either HIPAA or PSI, this business critical edition supports those requirement. It also do a data encryption anywhere. So anywhere you want to encrypt the data in Snowflake, that is supported in the business critical. It has some enhanced security policies because it's a business critical edition. So uh, that means you have a sensitive data and you need to secure that data. So that's why there are some enhanced security policies in the business critical one. Uh, there are some features of database failover or failback for business continuity. So you'll always have a support of if there is a failure happens into your Snowflake edition, there are always a database failover or failback policies exist into the business critical edition of Snowflake. After that, so all these four editions can run on a public cloud such as AWS, GCP, and Azure. If you want to run your Snowflake account on a VPC, which is a virtual private cloud, you could use the VPC edition of Snowflake. So this particular edition contains everything what you have in other editions. Along with that, you will have a dedicated virtual warehouse where encryption keys is in the memory. So that is a dedicated server is only given to that particular client who is using the VPC edition of a Snowflake. It also supports the customer dedicated metadata stores. So and additional operational visibility. So you will have additional visibility in your operations. That what is happening inside your Snowflake account. So these are the different editions of Snowflake currently we have, and based on your user or company's requirement, you can choose the edition accordingly. Hello and welcome to D Academy. So in this video, we are going to talk about the Snowflake architecture. It's a new architecture for data warehousing. It's a multi-clustered shared data in the cloud. So let's see about the traditional architectures we have before Snowflake. So there are two types of architecture we were following in the traditional world. One, we had a shared disk, and another one was shared nothing. So in the shared disk architecture is an architecture that is used in a distributed computing, in which nodes share the same disk device, but each node has its own private memory. Um, the disk has active nodes which shares memory in case of there is any failure. So all the data what you are have, it's going to sit into one disk where different nodes access the same data from the single disk. So one of the advantages is that any updates happen into the data into this disk, it will be simultaneously visible to all the different nodes from where you are accessing this data. But one of the challenges was that, like, if one of the node is trying to access the data from this particular disk, the other nodes might be in the queue states. So that's one of the challenges in terms of the shared disk. Now, in the what was the shared nothing architecture? Is an architecture that is used in distributed computing in which each node is independent and different nodes are interconnected by a network. So every node is made of a processor, main memory, and disk. So, so one of the advantages of there that if uh, all the different nodes are independent, so they can access the data from the disk independently. But one of the challenges is that you have to maintain the data at different locations, different desks. All right. So when the data is updating, it might the updated data is present in the first disk, but it takes some times to update into second and third disk. So that is one of the drawbacks in shared nothing architecture because it's a decentralized. Now, what Snowflake has done, it has used the benefits of both the shared disk and shared nothing architecture and creates its own architecture, which is nothing but a multi-cluster shared data. So in Snowflake, you will have a centralized location where all the data is set into one disk, but you will have different nodes, which is accessing the data from the same location. So it's a centralized scale out storage with multiple independent compute clusters. So whatever processors you are running on top of this data, they are independent. So there is no constraint on if one processor is trying to access the data from disk, the others will be in queue. So that issue is not in terms of Snowflake. So this is the modern architecture for data warehousing. Now let's see the different layers what we currently have in Snowflake. So currently we have three layers. The first is the cloud service layer. The second is the compute, which also called as a virtual warehouse layer, and the third is the storage layer where the data is going to get stored. Now let's see each of the layers one by one. So first is the cloud service layer. Um, the cloud service layer is called as a brain of Snowflake. It coordinates different activities across Snowflake, such as management, optimization of the queries, the security of your account. Make sure that your Snowflake account is available all the times. Any transactions processing which is happening on Snowflake will happen through the cloud service layer, and it also contains all the metadata of each and every objects of Snowflake. Now let's see all these activities one by one. So in terms of management, is it's a centralized management for all the storage. So whatever storage data you are storing, all the management of that data will happen through cloud service layer. It also manage all the computes that work with this storage. So any virtual warehouse what you build in Snowflake is all being coordinated by the cloud service layer. It's a built-in continuous availability, so it makes sure that your data is available across all the different zones 24 by 7. It's a fully online updates and patches, and it's all managed by Snowflake. So you don't have to worry about in terms of managing an infrastructure of the cloud service layer. It is all done by Snowflake. It also acts as an optimizer service. It has a SQL optimizer. So any code which you are trying to write in Snowflake, first it has to go through cloud service layer where it optimizes the code based on the standard and then run those onto the storage layer. It also help in automatic statistics gathering of the data so that your queries run faster and you should be able to get the results out of the tables quickly. It's also perform the transaction service. All the CRUD operations happen on your database will happen through cloud service layer. It's a fully ACID compliant, which is nothing but atomic, consistent, isolated, and durable. And it's also manage the concurrency. If multiple users are running the queries on your Snowflake, it helps in the concurrency of those queries in Snowflake. Um, all the securities what is being applied on Snowflake will be managed through cloud service layer. So in terms of securities is your authentication, that who is trying to access the Snowflake account. If they don't have a proper credentials, the cloud service layer makes sure that they will not be able to log into your Snowflake. It also helps in the access control for users and roles. So different users and different roles what you create in Snowflake is all managed by the cloud service layer. uh, it's also help in encryptions and key management. So any data which you're trying to encrypt through any keys, it's all managed by cloud service layer. So these are some of the features of cloud service layer. The next layer is the data storage layer. This is the layer where we store all the data. So the data storage layer in Snowflake is a hybrid columnar structure. It works on a concept called micro partitioning. Um, so what is micro partitioning is it's a continuous unit of storage that holds the table data. So as a default, you can create a micro partition of 50 to 500 MB, which contains can uncompressed data. But if your data is compressed, it generally maximum it goes to 16 MB. You could have many micro partitions per table. It's immutable. So once you create a micro partition for a table, you cannot go and update that. If you're making any update into the data, the Snowflake will create a different micro partition and store the updated data into a different micro partition. So this micro partition is going to help you in some of the features like fails such as time travel, where if you lose the data and you have a detention applied on your table, you can easily retrieve the data from Snowflake. So micro partitions helps us because it's immutable. You will not change the micro partition of a table where some data is stored. So that's always going to help you in terms of retrieving the older data from your Snowflake. Now, so this is the micro partition. So let's say you have a table where you want to store the IDs and name, and these are the rows which you want to store it. So what Snowflake internally does, it creates two micro partitions. So in first partition, what it does, it store the data from 1 to 3, and in the second partition, it store the data from 4, 5, and 6. So whenever you are running a query, and if you have where condition where you want to fetch the ID, the record which has ID of 3, so Snowflake automatically understand that okay, the ID 3 is stored in partition 1. So what it does, it directly goes to partition 1 and bring the data from that particular partition. It does not scan the partition 2. And that's make sure that your queries run faster because all these informations are stored into your cloud service layer. So this is how the micro partition store the metadata. The cloud service layer store the metadata of each of the micro partitions. Now the last layer is the compute layer. So compute layer is where all the resources are available to run your queries. So it's nothing but a wrapper around a cluster of servers with CPU, memory, and SSD in the cloud. Okay, and it works in on a t-shirt sizing concept where you could have a virtual warehouse starting from extra small and it goes up to 6 XL. Uh, the larger the warehouse, the more server in the cluster and more resources you have. So if you want to run a complex query and that is not able to run in a small warehouse, you can always increase the size of the warehouse where you'll have more resources, more memories and more CPU so that your queries will run faster. Uh, Whenever you are running a virtual warehouse, that means your SQL queries are running on your Snowflake and that is going to charge for the compute, whatever it's going to take as part of execution of your SQL queries. So this is the concept of virtual warehouse. Now, if you see, you could create multiple warehouses for different types of activity. So if you see here, your data is at a central location, which is nothing but your prods database. And if you see, somebody is doing a reporting out of the data, somebody is creating interactive dashboard. There is an ETL process which is running every day, and then there is an ETL and maintenance what you are doing. So for each of the activity, what you could do, you could create different warehouses based on your use case and the capacity on which the data you want to execute. So your data is coming from a single location, but you will have different processes with the different sizes of the warehouse running on top of that, so that it is not impacting the work of one team compared to what the other team is doing. So this is how the workload segmentation will happen into Snowflake. Now, there are two types of warehouses currently we have in Snowflake. One is the standard warehouse and another one is multi-cluster warehouse. So in the standard warehouse, you will have a simple single compute cluster. You cannot scale out. So whenever if you're in future, if your queries increases or then it cannot scale out automatically in terms of the standard warehouse. But the other one is a multi-cluster warehouse, where where you will have multiple single compute cluster work together, and it only available after the enterprise version. So if you want to scale out your warehouses, you can simply add different clusters inside your warehouse to help to help achieve the concurrency in your queries. Now, as we mentioned, it works on a t-shirt sizing where you have started from extra small to 6x larger. Um, so this is how you can increase the size of the warehouse based on your use cases. Now, as we mentioned that that Snowflake works on a credit system, so credits are how you build for a compute user. You could have a certain number of credits, or you could be build monthly for your credits. Credits are charged based on the number of virtual warehouses you use, their size, and how long you are going to use them to run your SQL queries. Uh, the usage is charged per second. So every seconds when your queries are running, it is charged per second with the minimum of 1 minute. So whenever you execute your query for the first time, the Snowflake will charge for entire 60 seconds, and after that, it only charge for per second when the queries are running. So this is how the credits works and based on different sizes of warehouse. If you have extra small warehouse, you will have one servers, and if you run um, your queries 1 hour into extract small warehouse, it is going to charge you one credit. So one credit in terms of, you understand, it going to be $1. And as you increase the size of the warehouse, your number of servers will increase, and the same credits, if you run the same queries for 1 hour into the 4xl large, it is going to charge you 128 credits, which is nothing but $128. So this is how the the credits works in the size of different size of the warehouse in Snowflake. Now, there are concept of scaling up and scale out in Snowflake. As we mentioned, scale up is nothing but you increase the size of your warehouse. So let's say you are running your queries on a medium warehouse where you are not able to run your existing queries, and because the queries are complex and you want to increase the size of the warehouse so that you will have more CPUs, RAMs, and SSD, then you can increase the size from, let's say, medium to large, and your queries will run faster. So this is a scale up for performance in Snowflake. If you want to scale out, that means you want to add new servers into your cluster to help you in terms of the concurrency. Let's say currently you have 10 users who are running queries on Snowflake, and for those 10 users, the Snowflake is able to accommodate all those 10 users queries. Now suddenly your number of user increases from 10 to 50. The queries are going in queue and it's running longer. So at that point of time, if you want to scale out your Snowflake, you can just add a server inside your Snowflake warehouse, and what it does, it automatically cater the different set of numbers of users what you have just added into your Snowflake account. And this is all happen automatically by Snowflake through scale out performance in Snowflake. So these are different layers of a Snowflake, and this is the architecture of Snowflake currently we have. Hello and welcome to the Academy. In this video, we are going to see how to set up a free trial account in Snowflake. So to set up a free trial account, just search for Snowflake in Google and open the first link uh, over here. Once you are in the Snowflake page, you should be able to see an option called Start for Free. Just click it. After clicking, it will ask you to provide some of your personal detail to start a 30 days free trial account for Snowflake. So just fill all this information and provide a company email. It could be any email. You can provide a personal email also here. Company name, you can give any name. It could be a dummy name also. In the role, you can choose a data engineer and select the country from where you are creating it. Once you fill all this information, just click it to continue. Here, in the next page, it will ask you to choose the edition of a Snowflake. So let it be the enterprise edition, and you need to provide the cloud provider where you want to deploy your Snowflake. So in this video, we are going to select AWS as our cloud provider. Once you select that, then automatically it will select the nearest region of AWS based on your country. Now, once you have all this information, just check this box and click on get started. Now, on the next page, it will ask you a few questions. So let's click it. So why are you signing for a trial version? Just select the training and certification, click continue. What will you use Snowflake for? So you can just select load data, build data pipelines, or migrate existing warehouse. Click on continue. Select your preferred language to work in. Here we are going to use SQL, so just select SQL, click submit. Once you answer all the questions, you'll get an notification that an email is sent to your given email ID to activate your account. So let's go to the email ID, whatever you have given over here. So this is my email ID. So I have received a email from Snowflake where it is asking it to activate by clicking this button. So just click this. After clicking, it will come to a page where it is asking you to provide a user, like set up a user name or the password which is going to be used for any future login to Snowflake. So let's set up a username. So I'm going to call this username and I'm going to set up a password for the same. Once you provide your username and password, click on get started. And remember this user and name and password because this is the ones which you are going to use going forward. So now once you provide the username and password, you are in the Snowflake and your so just click on skip for now and you should be able to see that your trial account has been created, which is going to end in 30 days. So this is how you are going to set up uh, your Snowflake free trial account. So for future reference, just bookmark this page so that you're going to remember this URL. So click on done, or you should be able to get the URL, login URL over here in your email also once you set up your username and password along with your username and password, whatever you have set up the password, just keep that, just remember that password. So this is going to be your dedicated login URL going forward, so you can keep that handy for your future reference. So this is how you are going to set up a free trial account in Snowflake. Hello and welcome to the Academy. So in the previous video we set up the free trial account for Snowflake. In this video we are going to overview the Snowflake UI. We'll check out different options what is available in the Snowflake UI, which is going to help you in the upcoming videos. Now to log into the UI, just open the dedicated URL which you have received, and once you open that, it will ask you to sign in by providing the username and password whatever you have set up. So let's provide the username and the password over here whatever you have set up in the previous video. Once you provide the username and password, just click on signing. Once you are signing, this is the home page of Snowflake where you can see the different options on the left hand side. So now let's see these options one by one. So this is your home page. So once if you want to come to your home page, just click on home page and you should be able to come over here. This is the search option where you can search anything inside this account, any database, any tables you want to search it. You can just come back here and search it. In the projects, this is the place where you can write all your SQL queries. You can create your notebooks. You can create your Streamlits application, dashboards, or any apps. Under the worksheets, if you see, there is the Snowflake already provides some of the default worksheet for you to practice. But if you want to create any new worksheet, you have to click on this plus button. Okay, and this will create a SQL worksheet for you. So if I go back to my home page and go to the product again, there are two options here. Either you can create a SQL worksheet or a Python worksheet. So based on your requirement, you can create a SQL or a Python worksheet. Now, so these are different options under the projects. Then other option is the data. On the data, you will able to see all your databases what you have created in this particular account. So by default, Snowflake provides two of the database. One is the Snowflake database, which is nothing but kind of a metadata database where all the account related informations are available over here. The another one is a Snowflake sample data. So this is one of the database where Snowflake provides few of the schemas where you have some of the tables where you can see already existing data. If you want to practice any SQLs on that data, you can leverage this particular database and the tables inside these databases. So this is, if you want to create a new database over here, you can simply click on plus here and give the name and create the database. So this is how you can create a database through UI. But if you want to create a database through a SQL statement, you have to go back to your worksheet, open a new worksheet, which is the SQL worksheet, and then you can write a statement called create or replace database, and whatever database you want to create that. All right, so this is how, there are two ways you can do that. I either uh, in Snowflake you can create the objects in two ways. Either you can go and create those in the UI, or you can write a SQL statement or DDL or DML operations to create those objects. Now on the data products, this is the marketplace or the different apps which is installed into your account. Though this is not being used as of now for data engineers, but this is also an options where you can explore this one. Now, if you want to do any AIML over here, all the features, branches, models, all the features, models, and document AI should be available here. So you can leverage that from here. Um, any monitoring you want to do it, like you want to see all the queries what you have ran, you can just come under monitoring. You will have a query history, where you can see all the queries what you have run till now. Uh, Under the copy history, any copy command which you have executed in Snowflake, all those information will be here. If you have created any task, and the details around those tasks will be available here in the task history. Then any information about dynamic tables, you should be able to see under the monitoring section. Under the admin, here it's all related to your account admin part, where you can see the cost management of your account, the overview, how much currency you have spent, how many currency you have in credits, how many you have left, uh, how the consumptions look like based on different filters. You can create a resource monitor also here, where you can track all the cost associated with your account. All the warehouses what you have created. So by default, Snowflake creates these two default warehouses, one for SQL and one for the notebook. So you can use these existing warehouse, but if you want to create any new warehouse, you can just click on plus warehouse. You can create a new warehouse, or you can create the warehouse through the SQL statement also. Any users or roles what you have created in Snowflake can be seen over here. All the information related to the accounts what you have. So this is the one of the active accounts what you have. So that information would be here. Anything related to security, the billings and everything would you should be able to see from here. Now let's go ahead and open a SQL worksheet. So this is the SQL worksheet where you can write all the SQL queries to run them. Now, if you see, when in Snowflake, when you are running a query, your query should be associated with a role. So all the accesses in Snowflake is given based on the roles, and those roles will be assigned to different users, which is present into your Snowflake account. So here you should be able to see some of the default roles already exist. Account admin is the topmost role, which is going to have access to perform any activity into your Snowflake account. Under account admin, you will have different roles like org admin, security admin, system admin, or user admin. So these roles will have different actions to perform. But as of now, we will always going to be use the account admin, because this is our own Snowflake account, so we can use that. To execute any SQL statement in Snowflake, you need to have a warehouse. So warehouses are nothing but it is that kind of a nodes where all the resources are available to execute your queries. So before running any SQL statement, you always have to select your warehouse and the role, and based on that, if you have access to certain objects or not. If your role does not have access to certain objects where you want to run the SQL queries, the Snowflake will throw an error. So always select your respective roles and the respective warehouse before running any SQL statement. You can either select these roles and warehouses from here, or you can simply run uh, select statement saying that use role account admin. This is also one way through which you can use the roles, and the same statement like uh, use warehouse, where use house, and you can pass the respective warehouse. So this is the roles and the warehouse which I want to execute. Now to execute this SQL statement, what you have to do is like simply select it, the statement which you want to run, and every SQL statement in the SQL worksheet should be ended with a semicolon, because if you don't put a semicolon at end of each of the SQL, what is Snowflake understand that this entire thing is a one SQL statement. So when you're trying to run this, it will probably fail because it's saying that there is an error, unexpected error at the use statement, right? So every SQL statement what you're writing in Snowflake should always end with a semicolon. So to execute this, either you click anywhere into the line which you want to execute, or you have to simply select that and click on this play button, and it will execute that particular SQL statement. If you want to run both of them, so both of these SQL statements should be ended with a semicolon, and you select both of them and execute them. It should run both of them one after another. So this is how you should execute a SQL statement inside a Snowflake. Hello and welcome to the Academy. In this video, we are going to understand what is Snowflake users and roles. In Snowflake, users typically refers to the someone who uses Snowflake to perform certain activities. Users of Snowflake can perform various tasks related to either a data storage, processing, or analysis. Each user may have a different level of accesses and responsibilities within the Snowflake environment, depending on their roles and permissions given to them. Now, what is a Snowflake roles? So, roles defines what actions a user can perform and what data they can access within the Snowflake environment. It helps manage permissions and ensure that user only have the access to the resources they need for their work. So if you see in this diagram, so we have different users like Sridhar, Anna, Evan, or Jen, and we have different roles like prod, test, dev, and analyst. And each of the users is assigned a respective role. So if you see, Jen and Anna has a prod roles. Sridhar, Evan, and Anna, which is SEA, has a test dev role, and Jen and Sridhar has an analyst role. And all these roles will have different permissions given to them, right? So in a prod role, probably the access is given to the users is only to select the data from your production tables or the views, right? In the test and dev roles, probably they would have more accesses where they can perform activities such as creation of a new tables, deletion of the data from the tables, or dropping any tables, and all those activities. So based on the roles, your accesses change, right? uh, Similar to that, if you have a role called analyst, it would have a certain level of accesses where it can access only the data related to certain tables. So this is an overview of users and roles. Now let's see how do we see all the roles and users in our Snowflake UI. So when you log into your Snowflake account, on the home page you should be able to see an option of admin. Under the admin you should be able to see users and roles. So if you click that, here in the first tab, you see all the users which is currently available to this particular Snowflake account. So the first user is the one user which I have created while creating the free trial account, and this is the default user what Snowflake creates to you. So if I open this particular account, it will give us some information about this user, where the default warehouse is associated is the compute warehouse. The default role given to this particular user is an account admin, and what all actions, what all grants roles which is given to this particular user is the account admin or admin, right? So this is certain information about this particular user. Now, if you want to create a new user, uh, you can simply click on this plus user, and you can provide the username, email, whatever the password you want to provide to that particular user. And under this advanced option, you could have options like login name. What is the login name which you want to give it? What is the default role? What do you want to provide to this particular user? And what is the default warehouse you want to give it to this user? So this is how you can create a new user, create a password for that user, and give it to somebody whom you want to give an access to this particular Snowflake account. So this is how you can create the user. Now, if you come to the roles, there are already some system defined role what Snowflake creates, right? So these are the system defined roles such as account admin, org admin, security admin, system admin, and user admin, right? So account admin is the topmost role inside the Snowflake. If you want to create a new role where you want to restrict some accesses to certain databases or tables on a schema, you can just create that role, and it's if you want to grant this role uh, the permissions of an existing role to this particular role, you can select that role, and while creating this role, all the grants which is available to the existing roles will automatically move to the new role. So this is how you can create a role, and once you create that role, you can come back to the user and assign that role to a respective user by just simply edit here. If you come to here, my default role is account admin. If I already have created another role, if I want to give this role to this user, I can just simply select that role and give it to them. So this is how you can create users and roles in Snowflake, and based on these roles, these user will have specific accesses and responsibility within the Snowflake environment. Hello and welcome to the Academy. So in this video, we are going to talk about Snowflake database and schema. So in Snowflake database and schema, logically organized data within Snowflake account. A database is a logical grouping of schema uh, where you could have multiple schema based on your different use cases or the departments in your organization, but each database belongs to a single account. So you cannot have multiple databases in the same account, but you could have multiple schema across different databases in the same account. Now, schema is a logical group of database objects such as tables, views, streams, pipes, store procedure inside the Snowflake. So let's see how we organize all the different objects of Snowflake. So if you see over here, all Snowflake objects reside within a logical container, with the top level container being the Snowflake account. So if you see here at the top level, you will have a Snowflake account. All objects are individually secureable. User can perform operations on object in the system via privileges and the granted to the roles, and the roles are granted to the user. So uh, under the account, you will have different users, you will have different roles, and these roles will have different privileges which are granted to these roles. And now these roles are assigned to different users. So in an organization, you could have multiple users and multiple roles based on what level of accesses you want to give to those users. You could create different roles. Now, to run any SQL statement or any queries, you need a warehouse. So warehouse is nothing but is kind of a resource where you have RAMs, memories, and everything to execute your SQL queries. So those are the warehouses. Resource monitor is nothing but if you want to create any object to monitor your resources within your Snowflake, such as how many credits you have consumed in Snowflake, those kind of resources you can create in resource monitor. After that, you will have databases. So as we discussed, databases are nothing but it's a logical grouping of all the schemas. Now under the database, you will have a schema. And now under schema, you can create other different objects such as tables, views, store procedures, pipes, file format stages. These all different objects we will talk about into upcoming classes. But all these objects needs to be created inside an schema, and that schema will sit under a database. So let's see in Snowflake, how do we create a database and how do we create schema. So let's log into your AWS console. Once you are in the AWS console, click on projects. Under the projects, you have to create a worksheet to run the different SQL statements to create a database or a schema. So there are two ways you can do that. One, either you can create the database and schema through the UI itself, or you could have run the different DDL operations to create the database and schema. So if you want to create the database and schema through an UI, you have to go inside the data section here. Under the data sections, you will have different databases. So as of now, currently, by default, Snowflake will give you two databases. So these are the Snowflake database and Snowflake sample data. So this is already when you create a new account in Snowflake, or Snowflake will automatically give these two databases. You cannot modify or drop these databases because this is by default given by Snowflake. Now, if you want to create a new database over here, you just simply have to click a plus database. It will ask you to provide the name of the database. So let's say if you want to create MyDB, and if you want to get any comments, something like that, so you can give that comment, and once you hit a create, it will create a database for you. So this is one way to create a database. Now if you see, my database has been created over here by through UI. Now if I refresh this page, I should be able to see the database over here. So under that database, by default, Snowflake will give you two schema. One is the information schema. This is nothing but it's kind of a metadata of all of the different objects inside this database, right? So if you create any tables, views, uh, streams, tasks, all those objects related informations, the columns related information will sit into the information schema. Snowflake also gives you a public schema, which is a by default schema. If you want to create a new schema, you have to just go inside the MyDB and click on plus schema, and then you can create any schema based on your use case, right? So let's say if I want to create a my schema here, so I'll just create a my schema and hit create, something like that, right? So let's create this through UI, and we will see how we can create these through SQL statements also. So your schema is created. Now if you refresh this, you should be able to see your schema under your database, right? So under a database, you will have different schemas, and under each of the schema, you can create different objects like tables and views that we can see. So this is how you can create a a database and a schema inside Snowflake through UI. Now let's see how do we create these databases and schema through a SQL statement. So first, let's go ahead and drop these. Now I'm just dropping it so that I'll show you how we can create this schema and database through DDL operations. So now I've dropped the schema, and now I'm going to drop my database also. So now both of them is now dropped. Now to create these database and schema, we need to open a worksheet. So come to project, under project, you click on worksheet, and here you will create a new worksheet. Now to run any DDL operation, first you need to select your roles, because through that role only your database, your objects are going to get created into Snowflake, and you also need to have your warehouse. So for that, always before running any SQL statements, you set up your context, that which role you are going to use to run those statements, and on which warehouse you're going to run those SQL statements. So here you can use a use role command or use warehouse command to set up those contexts, or you could also select those roles and warehouses from here. So let's run these ones. Select the statement and click on play button. So now my role is set up successfully to account admin, and my warehouse is also set up uh, to compute warehouse. Now once you set up these, now let's create our database. So I'm going to write a DDL operation called create or replace database MyDB. Okay, so this is the SQL statement in the Snowflake to create or replace any database. So just execute the statement, and your database MyDB is successfully created. Now if you refresh this page, you should be able to see your databases over here. Now the same thing what we have seen through UI, it automatically gives you two default schema. One is information and another one is public schema. Now if you want to create a schema inside that, so you have to do create replace schema, um, and you have to do that you want to create this schema under the database, and you have to give a name called uh, my db dot my schema. Okay, sorry, so you need to just provide a my schema, because if you see, your database is already set up to mydb. Okay, so you just give the name of the schema and click on the play button, and your schema is also successfully created over here. So now if you come back and refresh this, you should be able to see your schema over here. So this is how you create database and schema. Now in the upcoming classes, we will use the same database and same schema to create different objects such as tables, views, and pipes, streams, and tasks. So this is how we create database and schema in Snowflake, and these are the uses of databases and schema in Snowflake. Hello and welcome to the Academy. So in this video, we are going to talk about what are different tables we have in Snowflake. So these are the different table types currently we have in Snowflake. The first is the permanent table. The other one is temporary, transient, and external table. Now, we in this video, we are going to talk about the permanent, temporary, and transient table. The external table we will take up into another video session. Now, what is a permanent table? So permanent table is nothing but it is going to be persist inside the your Snowflake account until you physically go and drop that table. Now, this is designed for any data which is going to require a highest level of data production and recovery. Uh, in Snowflake, there is a feature of you can retain the data inside in Snowflake so that it is going to help you in terms of your data production and recovery that we are going to talk about in upcoming videos. But if you want to store the data or protect the data to a highest level, you should always use a permanent table. This is a default table type. So any table what you create inside Snowflake, if you don't mention that whether what is the type of that table going to be, it automatically creates as a permanent table. Now, there are two features of Snowflake. One is time travel and one is fail safe. So time travel is the feature which is going to help you in terms of your data production and recovery. So in a permanent table, that time travel will go up to 90 days with an enterprise version. So you can store the data up to 90 days inside Snowflake for this permanent table, so that if there is any issue happen within that 90 days period, you should be able to easily retrieve the data from the micro partitions what we have in Snowflake. It also include a fail safe. So fail safe is nothing but if you have a, let's say, a time travel period of 90 days and you were not able to recover the lost data within that 90 days, there is always a 7 days grace period uh, from where you can retrieve the data through a fail safe option. So these are the two these are the different features of time travel and fail safe in terms of a permanent table. Now let's see what is a temporary table. So it's a persist table which is only tied to a single session. Think like a single user. So you create a temporary table inside a session. Whenever that session ends, that temporary table will be gone. So you will not be able to retrieve that table again once your session is closed. Uh, this is used for any transitory data. For example, if you are creating an ETL pipeline where you want to do some sort of simple calculation between your source data and a target table, you just create a temporary table inside your script. So that once your script finalized and data loaded to your target table, the temporary table will be gone from your databases. In terms of time travel, it only goes as maximum of 1 days. Either it could be a 0 or 1 days. Beyond that, you cannot store the data into your temporary table. Like you cannot apply the time travel beyond 1 days. There is no fail-safe option. So if you lose, if you're not able to recover your data within 1 day, um, you will not be able to recover the data from your temporary table through the fail-safe. Now, the third table is a transient table. This is always similar to your permanent table, which can persist until you physically go and drop the table. Okay, it's not tied to a single session, so multiple users can use that transient table. Uh, it is going to be it always used when you want to persist the data into Snowflake, but you don't need same level of data retention as you have in the permanent table, right? So there, it could be a alternative to your permanent table that simply you don't want to create multiple permanent tables because there is a data retentions of 90 days applied over here. So you have to apply the data retentions, and that is going to increase your cost, right, of storage. So if there are some data where you don't need that level of data productions, you are okay to store the data into a transient table. So in terms of transient table, your time travel and fail safe, time travel is applicable to only 1 days, and there is no fail safe option here. Now the third is an external table. So this is also persist until you physically go and remove the table. It is going to help you to access the data which is sitting outside of Snowflake. So let's say you have data in any cloud data lake such as AWS S3, Azure Blob Storage, or GCP bucket. And if you want to access the data in Snowflake, where you don't want to physically move the data from those storage to Snowflake, then you can leverage the functionality of external storage. It is only read only, so you're not able to manipulate the data inside these external tables. So whatever data is sitting into your storage accounts, you are only accessing that data in a kind of a tabular format through Snowflake by using the external table. uh, it does not have any time travel and fail-safe options applied on the external table. So these are the different types of tables in Snowflake. Let's see how do we create permanent, temporary, and transient table in Snowflake through SQL statements. Uh, we will take up the external tables in upcoming videos. So to create that, let's log into your Snowflake account and open a worksheet. So here, what we are going to do, first, we are going to set up our role by running this use role account admin statement. And we are going to set up our warehouse, which is the compute warehouse, where we are going to run all these SQL statements. Now, as we discussed in the previous call, that the structure of uh, the grouping of objects happens under a database, and under the database you will have different schemas, and under the schema you will create different objects such as tables, views, and all that, right? So these tables we want to create under our schema, which is my schema. So we need to use the schema, which is database mydb dot my schema. So let's run this statement to set up our context that going forward, any tables what we create, it will automatically creates under the mydb and my schema. So once you execute that, you should be able to see your database is now your schema is set up as my schema, and your database is now mydb over here. Now let's create a permanent table. So this is a statement, create or replace table. This is the name of the table, and these are the two columns through which we want to create our table. So here you see there is no types you have mentioned, that it is a transient table or temporary table. So this is by default creates a permanent table for you. So let's execute this. So now your permanent table is successfully created. Now, if you want to see this table created, just refresh this page over here. And if you come under your My Schema, you should be able to see there is a folder called Tables. And under the table, you have this table, which is the permanent table, what you have created. Now, let's create a transient table. So to create a transient table, the statement is same, create or replace. Here we need to specifically mention that this is going to be a transient table. Okay. In the permanent table, we have not mentioned that it's going to be a permanent table, but by default, Snowflake creates a permanent table. So this is while creating a transient table, you have to mention that I am going to create a transient table. So let's create the transient table with the same list of columns what we have in the permanent table. So now my transient table is also successfully created. Now let's refresh that, and you should be able to see your transient table created over here. Now, if I want to create a temporary table, the statement is going to be the same, create or replace. And here we need to mention as temporary. Okay. Table and the table name along with the column name. So let's create the temporary table. So this is how you should be able to create a temporary table. Now, if you refresh this, you should be able to see all the three tables, permanent, transient, and temporary table is created successfully. Now let's see how do we see that, okay, this is a permanent table, this is a temporary table, and this is a transient table, because here I've given those names as that I'm able to identify which is permanent, which is temporary, and which is transient, but in actual we don't mention these keywords into the table name. So to check the type of the table, you have to run a command called show tables, and show tables are going to is going to show all the different tables what you have inside this particular database and schema. So when you execute this, you should be able to see the three different tables what we have created. And if you see the kind of the table, so the first, the permanent table, the type, the kind is going to be table. That means it's a permanent table. The temporary table, under the temporary table, the kind is going to be temporary. So that means it's a temporary table. And if you see under the transient, the kind is going to be a transient table. So this is how you will able to understand which is the permanent table into your database or schema, and which is your temporary and which is your transient table. Okay. If you scroll little right over here, you should be able to see by default the Snowflake gives a retention time as 1 day. Like any tables what you have create, by default Snowflake will give a retention as 1 day. Okay. Now all these different options what we have over here. Now this is the retentions. So as we seen in the PPT, for the temporary and transient, the default is going to be a maximum of 1 days. Okay. For the permanent, you can go up to 90 days with the enterprise version. So our Snowflake account is an enterprise version. So let's see if we can alter this retentions to up to a 90 days. So let's say if I want to put a retention of 3 days into my permanent table, what I have to do, I have to just alter the table name, and I'm going to set the data retention in time. Data retention time in days is equal to 3. Okay. If I run this alter command, my retention on my permanent table is going to be get updated from 1 to 3. So now let's go and check this by running this show tables. And if you scroll on the right hand side, you should be able to see that for my permanent table, the retention is now updated from 1 to 3. Okay. And I can go up to 90 days. So let's see if I want to put a 90 days, I can run this and it should be automatically update. Now I come back and run the show tables, and you should be able to see that my retention of my permanent table is now set up to 90 days. Now if I want to do a 91 days, it will not allow because the maximum you can go is 90 days. So if I'm trying to run this, that it says that an error that its maximum allowed retention is 90 days. Okay. Now, if I want to alter the state retention of my transient table and temporary table from 1 to, let's say, I want to set it up to 2, if I run this statement, it will throw me error saying that it's an invalid property because for transient and temporary table, the maximum retention you go as 1 days. Okay. So this is how we create different tables in Snowflake, such as the permanent, transient, and temporary. So based on your different use case, you can create those different tables in your data pipeline when you're setting up into Snowflake environment, and you can change the retentions based on your use cases. Hello and welcome to the Academy. So in this video, we are going to talk about what are views in Snowflake. A view is in Snowflake is a database object which allows you to see the result of a query as if it were a table. Now let's see what are different types of views we have in Snowflake. So currently we have three uh, types of views. First is the standard view, the second is secured view, and the third one is the materialized view. Now, what is a standard view? So standard view is kind of a virtual table whose results are generated by running a simple query whenever the view is accessed. The query is executed dynamically each time the view is referenced in a query, so that the result are not stored for the later or the future uses. Uh, it is very useful in simplifying the complex queries and reduce redundancy. The next is a secured view. So secure view are a type of view in Snowflake that provides enhanced data privacy and security. So these views prevent unauthorized users from accessing the underlying data in the base table and restrict the visibility of the view definition to authorized user only. So whoever has access to these views while creating, they can only access the data from the base table, or they can only see the definition of that particular view. Now the last one is materialized view. So materialized view, it behaves more like a table, um, where the result of the underlying queries are stored in a cache for the later use. It also auto refreshed. Uh, so as soon as there is a change in the base data, the materialized view automatically get refreshed and store those data into the cache for the future use. It also supports the secure materialized view. Okay, now let's see in Snowflake, how do we create all these views? So for that, let's log into Snowflake account and open a worksheet where what we are going to do is, first we are going to set up the roles, warehouses, and the database and schema where we want to create all these views. So let's use role account admin, where I'm going to set my role. Now I'll set the warehouse where I'm going to run all these queries, and then the schema where we want to create all these views. So this is my DB, my schema. Now first we need to create a table, and then from that we will create all these different views. So I'm creating an employees table where I have these four columns called ID, name, department, and salary. And this is statement to create the table, create or replace table employees, and with the along with the four different columns. So let's create this table. Now your table is successfully created. Now let's refresh this page and you should be able to see employees table under my schema in MyDB. Now let's insert some data into this table. So these are the 5 records which I'm going to insert, where I have ID, name, department, and salary. So I'll just execute this to populate the data into my table. Now once I run the insert statement, I'm going to check the data from this particular table. So I'm going to run select star from the employees table. If I execute that, I should be able to see these 5 records which I have inserted here. Now my table is created. Uh, so as we discussed, the views is nothing but an abstract on top of your table where you can access the data. So first I'm going to create a standard view. So to create a standard view, we'll just write a statement called create or replace view. Will not specify. If you don't specify the type of the view, the Snowflake will create a standard view. So what we are doing is, from this employee table, we are only selecting all the employees who belongs to the IT department. Okay, and we are calling this view as IT employees. So I'm selecting ID, name, salary from this employee where my department is ID. So this is the query which is being used to create this particular view. So let's create this view. Now my IT employees table is created. Now let's go ahead and do a select star from this IT employees table. So you should be able to see only the employees who belongs to the IT department here. So if you see, uh, employee ID 2 and employee ID 4 belongs to IT department, and those are being accessed from this particular view from your base table. So your base table contains 5 records, but this view is only showing the 2 records which belongs to the IT department. So this is how you can create a view and restrict the data from your base table. So this is a standard view what we create. Now, if you want to create a secure view, what you have now, let's see, refresh this page and you should be able to see this particular view, the IT employees view over here. Okay. Now, let's see if you want to create a secure view. So you have to mention a keyword called secure while creating this view. So I'm calling this as create a view, and here I'm creating all the view which is going to contain all the employees belongs to an HR department. Okay, so let's create this particular view over here. So your HR employees view is also created, and let's select the data from this particular view, and you should be able to see only one employee which who belongs to HR department. So this is how we are restricting the data into this particular view. Now let's refresh this and you should be able to see that this is an HR employees and the type of the view is a secure view. Okay, so this is how we create a standard and secured view. Now, whatever roles we provide into this particular view while creating the secured view, they can only able to access the data from this view or able to see the definition of this view. Now, let's see how to create the materialized view. Now, let's see there is a requirement where you want to store the data uh, by aggregating the salaries based on the departments. Okay, so your base table contains all these records where you have department, you have employee IDs, you have name, and you have also have the salaries. But I want to create a view where it only shows the aggregated salary based on each of the department. Okay, so every time when we create a standard view, every time when we run the select star on that particular view, it uh, it compiles the data every time from the base table, like it aggregates the amounts every time when you are running a select star from the view, and then give the result. Okay, but in terms of materialized view, what it does, it when you create that materialized view, it do aut- automatically do the aggregation of your salaries based on your department and store that data into a cache. So whenever in future you are running a select star from that particular view, it behaves like you are selecting the data from a kind of a table. um, it does not go to the base table to do the aggregation every time when you are running a select star, but it fetches the data from the cache and give it to the user who is running the query. So let's see the difference in both the views where we are creating a standard view with this aggregation. So I'm creating an employee salaries table view, sorry, where I am doing a sum of the salaries based on the department. So this is going to create a standard view. So let's create this particular view. So my employee.salaries has been created. And now let's create the same query where I have the department and I have the sum of the salaries. But here what I'm doing is I'm creating a materialized view. Okay. To create a materialized view, you just need to give a prefix called materialized in front of view and it will create a materialized view. So let's create this materialized view over here. So now your materialized view is also successfully created. Now let's go ahead and do a select star from both the tables. So first I'm doing a select star from my standard view, okay, where I have did the aggregation of sum based on my department. So let's do that. And this is going to give me 4 records where for each of the department what it has done is just aggregated the salaries over here. Okay, so these 4 records I'm getting from this standard view. Now let's run the same select star on your materialized employee salaries. So if I do that, this time also I'm going to get these 4 records, 4 departments. Based on that, the salaries has been aggregated. Now let's see the behavior of both these select statement on the backend, like how they have performed. So to check that, simply go to query history, open the query history, and if you refresh your page, you should be able to see the first two, these two statement, the select star from employee underscore salary. This is the standard view on which you have ran the select star, and this is the materialized view on which you have run the select star. So let's open one by one. So first I'm going to open the employee underscore salaries. And if you go to query profile, you should be able to see that this query, what it has done, it first has scanned the table, which is this employee table. Okay. Once it fetch all the data from this particular table, then what it has done did it sums the salaries of the employee based on the department. Once it has summed that, then it has given the results out of to the user. So this is the behavior of a standard view. It first scan the table, fetch all the data from there, did the aggregation, and then given the output to the end user. Now let's go back and check the what is happen in the materialized employee dot salary. So if you open this one, go to the query profile, you don't see the table scan. Like you don't see the employee table over here. So what Snowflake has internally done, it has pre-computed those aggregated table when you created the materialized view and store that into a cache, and this data is coming from the cache. Okay, this when you're running the same queries both the time, right? Like uh, in the standard view and the materialized view, you're running the same query. Select department and sum of salary, select department, sum of salary from the employee group by department. So in both the cases, the query is same, but what is happening on the back end is that whenever you did a select star on the employee table into employee underscore salary, which is the standard view, every time it has to go scan the table, bring the data, do the aggregation, and give it to the user. Okay, but in terms of materialized view, Snowflake automatically does this aggregation on the backend, store the data into cache, and every time when you are running a select star, it is going to pull that data from that particular cache. So this is the advantage of using the materialized view. So if you have a complete uh, complicated aggregation which is same every time when you are running the query, so in place of creating a standard view, you create a materialized view and store those aggregation in the cache, and then start retrieving that so that your queries will run faster and you will not have to invest more of the resources while accessing the data. So this is the difference between a standard view and a materialized view along with the secured view in Snowflake. Hello and welcome to D Academy. So in this video, we are going to talk about stages in Snowflake. So a stage is a name storage location in Snowflake where you can temporarily load or unload data files before transferring them to Snowflake. It is going to help in simplification and streamlining the bulk loading and unloading process inside a Snowflake. Uh, the stages in Snowflake can be either an internal stage or an external stage. So internal stage are the stages which are stored internally inside a Snowflake. External stage is nothing but which is going to stored into an external location, which could be a cloud storage. The best practice in Snowflake is we should always create stage objects to manage ingestion workload in Snowflake. Now let's see the types of stages in Snowflake. So we have three types of stages. One is the table space stage, and another one is this user stage, and the third one is the name stage. So table and user stage created automatically. It's an internal stage. The name stage you have to create manually. And under the name stage, you could have an internal stage and external stage. So let's see all three of them. Now, what is the table stage? Table stage are linked to a specific tables in Snowflake. Whenever you create a new table, a corresponding stage is automatically created by Snowflake. Uh, they are named after the tables and owned and managed by table owner. So whoever has created the table and who is the owner of that table, this particular stage is being owned and managed by that particular table owner. Um, it's a convenient option if your file needs to be accessible to multiple users and need to be copied into a single table. In that particular use case, we will use the table stage in Snowflake. The next one is the user stage. User stage are the default stages that automatically created for each of the users. So whenever you create a new user in your Snowflake account, it will create a user stage for that particular user. Uh, it serves as a convenient choice if your files will only be accessed by a single user but needs to be copied into multiple users. So whenever uh, you use the user stage where your file needs to be accessed by a single user whose user stage you are using, but it can be copied into multiple tables. They are referenced using at the rate tilde sign, and these stages cannot be altered or dropped. Uh, Snowflake automatically creates, as we discussed, a user stage whenever you create a new user. Now let's see the name stage. So under the name stage, the first one is the internal stage. Name stage are database objects that provides a greatest degree of flexibility for data loading process. Unlike the two previous stages, which is the personal user stage and the table specific stage, name stage can be accessed by multiple authorized user and leveraged to load data into several tables. So this can be accessed by multiple users whoever has the required access to access this particular stage in Snowflake. and can be used to load data into multiple tables from here. Now under the name stage, you have an external stage. So Snowflake external stage are stages that store data into an external cloud location. So if you have any location where you have the files which is outside of Snowflake, if you want to access those files from Snowflake, you need to create an external stage for them. They are used to load the data from external location in Snowflake tables, or it also going to help you to export the data from Snowflake tables to external destination. So it works in both the ways. You can load the data from an external location to Snowflake, or also you can export the data from a Snowflake table to an external location through a named external stage. Currently, Snowflake supports the external stages with AWS, Azure, and GCP. Now, so these are the different stages we have in Snowflake. Now, let's see these stages in Snowflake. So for that, log into your Snowflake account and open any worksheet here. First, what we are going to do, we are going to set up our account role, our compute warehouse, and our schema to these particular values. So I'm going to run all these statements here. Now your role, warehouse, and schema is successfully created. Now I'm going to create a customer table here, which has 4 columns called ID, name, age, and state. And I'm going to use this table to demonstrate different stages, such as our table stage, internal stage, and we should see how do we load this data into this table by using these different stages. So first, let's create this table here. Now, as soon as you create a table in Snowflake, Snowflake will automatically create a table stage for this particular table that can be accessed with this particular command. So what we are doing, we are listing all the files if there is any present into the stage, table stage related to the customer table, and that can be notified with the at the rate percentile symbol. So if I run this, I should be able to see that it can access the table stage. Currently, we don't have any file or in this particular stage. Now, the second one is the user stage. So as soon as you create a user in Snowflake, the Snowflake will create a user stage for that particular user. So currently, this particular Snowflake has a user, which is this particular user. Now, if I want to access this, I just have to do a list at the rate and tilde. This will access your different user stages inside your Snowflake. So this will not give any result because currently we don't have any file over here. Now let's talk about the name stage. In this particular video, we will talk about the internal name stage, and in the upcoming video, we'll talk about the external named stage where we will create the stages to access the data onto an external location, which could be onto AWS S3 bucket. So there are two ways we can create a internal name stage into Snowflake, one through UI and one through a SQL statement. So now let's create first uh, through a UI, and we will upload a file and try to load that file data into this particular customer table. So to create a stage into Snowflake name internal named stage through UI, you have to go to your database and you have to go inside your schema where you want to create that particular stage. So since stage is a database object, it similar to tables and views, it needs to be created inside a schema. So I have gone to under the data, I have gone to databases, and then I have opened MyDB database and I went inside the my schema, and then over here, if you see a create option is there, if you select that, you will able to see an option called stage. Now there are two options. One is Snowflake managed and one is external stage. So as of now, we are creating the stage which is going to be Snowflake managed, which is going to be your internal named stage. So just click on that. Here it will ask you to provide the name of the stage. So I'm going to call this as customer underscore stage because I'm trying to load a customer file into my customer table. The schema is going to be mydb.myschema. And if you want to do an encryption, you can do it else. So here I'll do either client side or server side. So you'll see the option here. So let's do a client side, sorry, server side encryption here and do a create. So now your stage will be successfully created and you should be able to see there is no file currently available here. Okay, now we need to upload a file so that we can access that file to load into our customer table. So I have this file where I have a similar structure what I have currently for my table, where I have ID, name, age, and state, and file name is customer, and this is a comma delimited file. So I'm going to upload this file into my stage. So just click on plus files, and you can browse it or drag and drop. So I have already downloaded that to my local machine, so I'll just browse that and select that file, customer file. So this is the customer.csv I'm trying to upload, and I'll validate, okay, this is my schema and this is my stage where I'm uploading this. Now click on upload. So once you upload, now your file is currently available into your stage. Now, if you want to see this, if you want to load this file into your table, then what you have to do, you have to come back, and this process of loading this file we will do through UI, and later we will do the same activity through a SQL statements also. So let's come back to our tables, and in the tables you'll able to see I have a customer table here. So just click on that. Once you're inside the customer table, I need to do a load data. So click on load data, and it will ask that, okay, you want to upload from a file, yes, then browse it, else, or you want to add from a stage, which is nothing but an internal stage which we have just created. So click on add from stage here, and here you need to select the database, which is going to be my DB, and the schema is going to be my schema. And if you see, once you select the database and schema, you should be able to show you all the different stages what you would have. So currently we have only one stage, which is the customer underscore stage. So just select that, and this is the file which I want to load it. So select that and click add. Now this is this. Once you select that, you click on next. So Snowflake will automatically analyze that file, saying that, okay, the file format of this file is CSV, and these are the columns coming from file, which is going to map to different columns into the customer table. So ID is going to ID, name is going to name, age going to age, and state going to state. So if that is correct, just click on load. Okay, and your data should be successfully loaded, where you see that 5 rows is been successfully loaded into your table. Now you go back and query this data. So if I query that, it will open a new worksheet and automatically write a SQL query for you. Just select that and run this statement. You should be able to see the different records which you currently have into your Excel CSV file to your table here. So this is a one way where you can create a stage through a UI, okay, and then load that data through a stage to the table through UI also. Now let's see how do we do the same activity through SQL statement. So I'm just going back to my data here. So I'll click on done. So I'm going to go back to my database, and under the database I'm going to go back to my stage, and I'm going to first delete this stage because I'll create this stage through SQL statement also. So let's go ahead and drop this stage here. So first I'm going to drop this stage so that it will drop the file also. Now if you refresh this, you will not have the stage. Now I'll have my customer table also here. Now let's go back, and what I can do, let's go back to the SQL worksheet what we have, and here what I'm doing is I'm creating and replacing the stage through a SQL statement. So the statement is create or replace stage and the name of the stage. So let's go ahead and create that. So once you run this, it will automatically create the stage into your Snowflake, and this is the same process. If you refresh this, open this here, go back to your schema, you should be able to the stage through being created through SQL statement. Now we have to upload a file over here that could be done manually. So if you come back to your data under databases, just refresh that, you should be able to see the stage. Open the stage here, refresh that. You should not have any file now because this is now created through SQL. So just click on files, browse it, and select the file which you have used previously and upload it. So now your file will be uploaded successfully into this particular stage. Now you need to enable directory table to see the file. So just click on that and you should be able to see your file over here. Okay. Now we have to use this file to load our customer table through a SQL statement. Previously, we have done, we have done through a UI where we went here and click on load data and load it from the stage. Now let's see how do we do through a SQL statement. So come back to your SQL worksheet, and first we need to see that, okay, what all files we have into our customer stage that can be done through a SQL statement also. So the command is list and at the rate and the stage name of the stage. So just execute this. You should be able to see that there is one file into my customer underscore stage. The name of the file is customer.csv. What is the size? What is the MD5 of that? And when that file was last modified. So this is the file which is correctly validated through a SQL statement also. Now let's go back and truncate the customer table because you have already loaded the same file again. So the metadata of the file is being stored into Snowflake. So before loading the same file into the same table, we have to truncate the table so that metadata of that table will be lost. So let's truncate the table here and the data will be deleted. Now, if you see the select star from that table, you will not have any data over here. Okay. Now we need to load the data into the customer table from the customer stage by using a SQL statement. So this is the command where what I'm doing is copy into customer, which is the table name from at the rate customer underscore stage. That is the internal stage what we have created over here. And what I'm defining that the file which I'm trying to load in this table is of type CSV. Okay. And since my file has a header, I don't want to load the header into table. So that's what I'm saying, that skip underscore header is equal to 1. So whatever is the first row inside the file, it will skip it and load the remaining column rows into my customer table from this particular customer stage. So let's execute this particular command and you should be able to see that status as loaded. The file which you have loaded is customer.csv and how many rows I have loaded is the 5 rows which I have into my file also. Now let's go back and do a select star on this customer table and you should be able to see the 5 records what you have in the file is loaded successfully into your table. So this is how you can use an internal stage to load the data sitting into Snowflake itself to any table inside a Snowflake. In the next video, we'll talk about external stage and how do we load the same file if that is available into an S3 location, AWS S3 location, from there to our Snowflake tables. Hello and welcome to D Academy. So in this video, we are going to talk about file format in Snowflake. Snowflake file format is a named database object that can be used to simplify the process of accessing the stage data and streamlines loading data into and unloading data out of database tables. So whatever files in the previous video I've seen, we have created stages, and in that stages we were putting some files, and those files were being loaded into table. So file formats are going to help us identify what is the type of the file, what are different options we currently have in that file, such as that if the file is a CSV file, does that contains any header, what is the delimiter of that file. So those kind of information can be clubbed while creating a file format, and then that file format can be used while copying the data from the stage to the table or exporting the data out of a Snowflake table to a stage. Uh, a Snowflake file format contains information of the data files, such as what is the type of the file, whether it's a CSV or a JSON file, and any formatting options specific to each type of files used for bulk loading or unloading process. The recommendation is that we create the file format as part of the stage. When we are creating a stage, we can mention that file format, or we can specify within the copy command also. So we can check these while we will create the file format in Snowflake. Snowflake currently supports the below file formats. So we have JSON, we have CSV, we have Avro, ORC, Parquet, and XML. So these are the different file formats which Snowflake currently supports. Now let's see how do we create this file format and how do we use this file format while loading the data into Snowflake tables from an stages. So for that, let's log into our Snowflake account and open a new SQL worksheet. And in that, first we are going to set up the context for the role warehouses and the schema under which we are going to create these file format. So My role is going to be account admin, so I'll execute that. My warehouse is going to be the compute warehouse, and the schema where I'm going to create this file format is going to be mydb my schema, because this file format is also a database object which needs to be created inside a schema. So let's set up our schema also. Now once it successfully set up all the different context, uh, I'm going to create a table called student where I will have these four columns: ID, name, age, and marks. So let's create this table, and I'm going to create a stage for this particular table, which is I'm going to call as a student underscore stage, which is nothing but an internal stage. What we have seen in the previous video, we are going to put the file, and from this stage we are going to load that file data into this student table. So let's create this stage over here. Now my stage is also successfully created. Now if I do a list of at the rate student stage, I should not be able to see any file over here because I have not uploaded it. Now let's go back and upload the data into this particular stage what we have just created. So for that, we go to the databases. Under the databases, we'll refresh this page and go under MyDB. Under MyDB, we'll go to My Schema, and then we will go under stages, and we should be able to see there is a new stage called student underscore stage created over here. So just open that, and we will enable the directory table so that whatever files we upload here, we should be able to see that. Now currently we don't have any file over here. Now let's upload the file what we have. So currently this is the file what I have, where I have an ID column, name column, age column, and marks column, and I have 5 records inside this particular file. So I'm going to use this file to first put into the student underscore stage, and then from there I will load into a student table. So let's go ahead and click on this plus files under my student underscore stage. Once I that, click on browse and go select the file what you have inside your local machine, whatever you have created. So once you select this student.csv, you can just upload this file over here. So now you should be able to see the file over here. Now let's go back to our worksheet. By click on projects, we'll go back to the worksheet and open the worksheet where we are running the queries. Now if I do a list of at the rate student underscore stage, I should be able to see the file which I have just uploaded. So this is the file, this is the size of the file. Now my file is successfully uploaded. Now to load this file into a table, we will use a copy command. So what we are doing is copy into student from at the rate student underscore stage. So what we are doing is loading the data into a student from our student underscore stage table, and the file format, in that file format we were manually providing what is the type of the file, and my file contains an header, so I'm going to skip the first line as a header, right? Skip underscore header is equal to 1, which is going to replace the first row of the file. So here the file format is manually, we are providing the options manually over here. This is one way also we can mention the file format, but we will use how do we first hand create the file format and then use this file format over here, rather than replacing everything, rather than placing everything as manually. So if I execute this particular command, it should be able to load the data also successfully into the table. So if you see here, the number of rows loaded is 5 rows. Now if I go and do a select star from the table, I should be able to see those 5 records what I had into my file. Now let's see how do we use the option of file format to create beforehand, uh, and don't use the options directly in the copy command itself. So for that, let's truncate this table because we are going to use the same file to load into the same table again by using the option of file format. So let's first truncate this table. So now my table is truncated. Now this is a way through which we can create a file format inside a Snowflake. So what I'm doing is create or replace file format, and the name of the file format I'm going to call is as CSV underscore format. And what I'm mentioning is different option that the file, this particular format will only be used for the type as CSV. In that, the field delimiter is going to be comma because my files will be comma separated files. The record delimiter is going to be a new line character, and I will have file header into my file, so I'm going to skip the first row inside the file. So there are different options also in the file format we can use to create that, but this is the minimum for a CSV format file. So let's create the file format. Now my file format is successfully created. So if I refresh this page and go back under my schema, I should be able to see that my CSV underscore format has been successfully created over here. Now let's see how do we use this file format, what we have just created, in the copy command while loading the data from our stages to the table. So I'm going to run the same command called copy into the student table from the stage, the internal stage where I have the file, and I'm going to mention the file format as the format name what I have just created here. So my format name is going to be CSV underscore format. So if you see this particular copy command and this particular copy command, here I am mentioning the type and skip header all inside the copy command itself, right? But in this copy command, I am not mentioning anything, but all those informations are already exist into a file format which I have just created over here. So this is going to help you put everything inside a format, and then we can use this particular format across many copy commands what we are using in Snowflake. Every time when you are running a copy command, we don't have to explicitly mention all these information over here, as we have already put those information inside our file format what we have created. So now let's go ahead and run this particular command by using the file format. So if I execute this, this is also able to load those 5 records what I have, right? So if I go back and run the select star on this table, I should be able to see those 5 records. So if you see, by creating a file format, you have mentioned everything inside it. You are not mentioning everything while running a copy command, and just use the file format while running the copy command. So this makes easy. Uh, uh, this makes your code easy to read that, okay, which is the file format you are using, and by using that file format, you can go and check what all different options you have given into that particular file format. Now this is how we create a CSV format file. Now if you want to create a JSON format file, the syntax is going to be the same: create or replace file format. The name of the file format is going to be JSON, and the type you can mention as JSON. Here you don't have to mention other ones because that is specific to CSV, but for JSON the options will be different. So let's go ahead and create the JSON format file format also, and you should be able to see this is successfully created. Now this file format can be used to load any JSON file into your Snowflake environment, right? So when you refresh that, you should be able to see your JSON format is also created. Now to check all the different file formats created within that same schema, what you can do, you can execute a show file formats, and this will give you all the different file formats what you have created. So currently we have created 2 file format, one is CSV, one is JSON, and this is going to give you all the different information about that particular format, which database under which schema it has created, what is the type of those file format, and this is the different options. This is the by default options what Snowflake gives for any file format, right? For CSV, these are the different options what you have, which you can set up accordingly. But here, while creating, we only have set up the file field delimiter, record delimiter, and skip header. Rest everything is comes as it is as default from Snowflake, right? If you want to change a file date format, you can mention the date format here. It will automatically change from auto to whatever you are given into the file format while creating it, right? In the JSON also, you'll have these are the default list of options what you can set it up. Whatever you are passing while creating the JSON format, that will be updated over here. Rest everything will be as default what Snowflake provides it. So this is how you create a file format and use that file format while loading the data into a table from a stage in Snowflake. Hello and welcome to the Academy. So in this video, we are going to talk about the different data loading approaches in Snowflake. Uh, so there are 2 data loading approaches we have in Snowflake. One is a bulk load, what we do, and another one is continuous. So the bulk load is going to happen through a copy command from either your local file system through internal stages to a table, or you can use you can do the same bulk operation from your external stage through the copy command to your table. So that's the 2 ways through which you can use the copy command to do the bulk operation. Uh, the another one is the continuous. data loading approach, where we use a Snowpipe to auto ingest the data coming from your external stages through an ingest queue and directly to a table. So these are the two different approaches currently we have in Snowflake to load the data from uh, different stages. Now let's see one by one. First, we are going to take a look into the bulk loading overview. So bulk loading can be done in two ways. One, uh, through an internal stage. If you have some data sitting onto your local file systems, what you have to do, you have to just upload that into internal stage and use the copy command to load those files from your internal stage, which is currently sits into Snowflake, to a table inside a Snowflake. So in the previous video, you have seen example where we have created stages, which is the internal stages, and uploaded the file manually inside that particular stage and use the copy command to load that file into our table. So that's one way to do a bulk loading. The another one is if your data is sitting into an external stages, which is built on top of either AWS S3 or Azure Blob Storage. If you have too much data, it's not practical to load all those files into an internal stage. So that's why we create external stage into the different cloud services, and from there, then we will use the copy command to move those large file into our Snowflake table. So we will see this particular example into upcoming videos, but this is two ways through which you can do a bulk loading. Now let's see how do we load from local file system. So there are three ways which we can do it. One, if you have a data into a local file system, what you put that file into internal stage, and from there you can run a copy command to load the data into a table. Or if you have a data into a local system, what you can do is you can directly put that file into a stage which is exist into a table, which is we call as table stage, right? And from there, then you can use the copy command to load the data into the same table. There is also a user stage. So if you want to leverage that particular one, you can put that file into the user stage, and from that user stage, then you can use the copy command to load the data into this particular table. So this is the three ways which we can uh, load the data from a local file systems into our table. Most preferred way is to use the internal stage. From internal stage, put the data files into an internal stage, and from that you can just run a copy command and load into the table, which you have seen in the previous videos. So this is an example. If you want to load it from a local stage, first you need to create a stage, and this stage will create it into your Snowflake, which is going to be internal stage. Now you use the put command, or manually you can upload that file also into that stage, and then run a copy command into a table, and from the stage what you have created, and all the files sitting into this particular stage will automatically load into the table. So this is an example. By using this, you can load the data from a local storage. Now, if you want to load the data from a cloud storage, then there are two ways. One, you have to create an external stage, which is going to reference your S3 bucket, and from there you can use the copy command to load the data into your table, or you can directly uh, use the S3 bucket location and run a copy command on that and load into a table. But this is not a recommended way to do that, because creating an external stage will put some sort of security measures on top of that. And so Snowflake always recommends to create external stage and then use that external stage to copy the data from S3 bucket to a table inside a Snowflake. So we will see this example into upcoming videos. How do we create stages on S3 bucket, and how do we use the copy command to load the data from that particular bucket to our table. Now, here is an example how we can create it. So first we need to create a stage which is going to be external stage. Um, is going to be using the URL from where you want to load this file, which is the S3 location over here. You need to provide the credentials of AWS key ID or secret key, and then you need to provide the file format. This is a one way of doing that, where you are passing the credentials and the secrets key, which is not a recommended way. Now we use a storage integration. There is a object inside a Snowflake which we call as a storage integration. That storage integration contains all the security measures of the particular AWS account from where you are trying to access the file, along with the URL of S3 bucket. So we will see how do we first create that storage integration, and by using that storage integration we will create a stage, and from that stage then what we do, we run a copy command into a table from the external stage from where you are accessing the data and then load into that particular table. So this is how you can use the external stage to load the data to your Snowflake table. Now let's see the second approach where we want to load the data continuously into our Snowflake. That can be done through a Snowpipe. So this is the use case where you can apply either the copy command or a Snowpipe. If you are migrating from a traditional data sources where the data is coming into batches, you can use the copy command option to load the data into batches. If the data is coming from a modern data source such as an API or Kafka or Kinesis inside a Snowflake, then the best option is to use the Snowpipe, because continuously the data is coming from these modern data sources and you have to ingest that data into your data warehouse. So you can deploy Snowpipe. Uh, so in terms of the batches, it's the batch is nothing but a micro batch where you are running this into small batches and loading into your Snowflake and Snowpipe. It's a continuous, so every 1 minute the Snowpipe will buffer the stage and see if there is a file, and based on that file, it loads that data into your Snowflake environment. There is no scheduling involved into Snowpipe, but you have to schedule your copy command in terms of the batch process. This is scaled compute resources for different. So you can use a different compute resources for different ingestion workload. If you have too many files, you can use a larger warehouse. If you have small files, you can use a small warehouse. But Snowpipe also gives you a serverless model where you don't have to specify the virtual warehouse. Snowflake will automatically take care of that based on the load which is currently running as part of the Snowpipe. So this is how you can differentiate and use copy command and Snowpipe based on your use case. Now let's see how Snowpipe works. So Snowpipe is nothing but it also contains a copy command which is used by Snowpipe where you have the source stage for the data files and you will have a target table where you want to load that. So these are the two commands you use into Snowpipe. Loads the data into table continuously from an ingestion queue. So whenever you create a pipe, it automatically creates an ingestion queue for you, and you have to use that ingestion queue to automatically send the notification from your external storage, which is nothing but in terms of AWS, it's going to be S3 or it could be a blob storage. So from there, you will get a continuous notification to your ingest queue. Uh, Whenever you upload a new file or whenever the process uploads a new file into that particular location, and the pipe will continuously monitor this ingestion queue, and from there automatically it runs the copy command and load the data into your table. There are two ways you can use a Snowpipe. One is the Snowpipe REST API. So if any application is using a REST API, you can call the Snowpipe REST API, and from there you can load the data into a Snowflake table. You just need to create the pipe with this particular command where we are doing create pipe the pipe name as copy into the table from the stage. So by using this pipe, you can automatically call that REST Snowpipe REST API and load the files from the stages to a database. So this is somehow a micro batch, but if you want to do a continuous ingestion, you have to use the option of auto ingest. So auto ingest is going to help you load the data from different streaming platforms such as Kafka or Kinesis Data Firehose. If you have a data coming from these and landing into your external cloud storage such as S3 in AWS, then S3 is going to send a notification whenever there is a new file come into this particular cloud storage, right? And Snowpipe will automatically create a SQS channel in which the notification is going to come, and then Snowflake will automatically run this Snowpipe because you will set the auto ingest is equal to true, and then as part of the serverless approach, this will load the files from this external cloud storage to your databases. So this is how we will leverage the auto ingest in a Snowpipe to continuously ingest the data from our external source to a table inside a Snowflake. So we will see this into hands-on practice. Where we will create Snowpipe, and by using that Snowpipe, how should we automate the process of auto ingesting the data from our external cloud storage to our Snowflake in the upcoming video. So these are the two ways through which you can ingest the data in Snowflake. One is if you're doing a bulk loading, you can use a copy command manually. If you want to do auto ingest or continuous loading into the data, which is getting generated through the modern data platforms such as Kafka and Farhouse, then you can use the Snowpipe option of auto ingest, where you can load the data from your external cloud storage to Snowflake. Hello and welcome to the Academy. So in the previous videos, we have seen how have we used the copy command to load the data from the internal stages created inside the Snowflake into different Snowflake tables. In this video, we are going to see if we have a data file sitting into our external cloud storage. In this case, it would be an AWS S3. Then how do we load that data from our AWS S3 to our Snowflake table? By using the copy command through an external stages. So to create this external stages, let's you need to have account in AWS along with your account in Snowflake. So let's open both the accounts of your Snowflake and AWS. Uh, First, we are going to set up the context inside Snowflake, where we are going to create all the different tables and external stages to load the data from our S3 bucket. So here I'm using the role as account admin. So let's use the role as account admin, the warehouse as compute warehouse, and the schema is going to be the MyDB my schema, what we have previously created. Once all the different contexts are set, here I'm going to create a table called user, and it is going to have 4 columns called ID, name, location, and email. And this is the table where I'm going to load the data from the file which I'm going to upload in S3 bucket into this table by using the copy command. So first let's create a table. So now my user table is successfully created. If I can refresh it and come back here, I should be able to see my user table over here. Now this is the file which I have, which is the user file, where I have the ID, name, location, and email, and I have these 5 records into this particular file. So what I'm going to do is I'm going to upload this file into an S3 bucket. Then on top of that S3 bucket, I will create a storage integration and external stage. And then using the copy command, I am going to access this file from an S3 bucket and load these 5 records into my table. So to load this file, first we need to create a storage integration into Snowflake. And before creating that storage integration, we need to set up the the buckets and the IAM policies in AWS. So let's log into your AWS management console, and in the search bar, search for S3. Once you are in the S3 bucket, you should be able to have a previous bucket created. If you don't have any bucket, let's go ahead and create a bucket by simply clicking on create bucket and then give the name of that bucket accordingly. I already have a bucket created, so I'm not going to create that. So this is the bucket which I'm going to use. So my bucket name is the Academy Training Bucket. Now, once you have your S3 bucket set up uh, correctly, then let's go ahead and create the IAM role, which is going to used in the storage integration to set up the connection between your S3 AWS S3 bucket and Snowflake. So let's open in the search bar, search for IAM and open the IAM. Once you are in the IAM page, click on roles. And here we are going to create a role. So to create a role, simply click on create role. Under the select trust entity, we need to select the option of AWS account, because this is going to be used when you are trying to access, when a third party is trying to perform something on some action on this particular account. So this options we choose when, in this case, our third party is going to be Snowflake, who is going to perform some action of pulling the data out of your S3 bucket. Now, once you select AWS account option here, you need to also check box check this box where it is asking is to require an external IDs. So this is a best practice when third party is going to assume this role. So just select this option, and under the external ID, as of now, let's give a default value of 0000. Later we will change this external IDs once we have the storage integration created inside our Snowflake. Once you fill this, click on next. Now we need to add the permission into this particular role. So this role should have an access of accessing any file setting into an S3 bucket. So it should have a full access of S3. So in the search bar, search for S3 full access, and you should be able to see already a policy name with the name of Amazon S3 full access. So simply select that policy and click on next. Now under the name, review and create section, it will ask you to provide a name of this role. So I'm going to call this as Snowflake role. If you want to provide a description, go ahead and provide that, and just validate that this is the trust entities which you have, where you have the external IDs giving as default, and under the permission, you should have Amazon S3 full access. So once you verify everything, just hit the create role. Now your role is successfully created here. Now let's search for this role. So I'm going to search Snowflake role, and you should be able to see your newly created role. So just click on to open it. Now your role is successfully created in AWS. Also, you have set up your S3 bucket. Um, so once that is done, let's head back to Snowflake. And after creating the table, we are going to create a storage integration. So storage integration is an object that store a generated identity and access management entity for external cloud storage. So it is going to store the IAM role through which you are trying to access the S3 location, and also it will provide you the S3 location from where you want to access the file. So if you see the statement of creating a storage integration is nothing but create or replace storage integration, name of the storage integration. Here the type I am going to mention as external stage because this is going to be used in while creating this stage. Storage provider is going to be S3 here. You could have a different option for GCP and Azure also, but here we are using AWS, so we have provided S3. We have enabled it, which is a true option, and here under the storage AWS role ARN, we need to provide the ARN of the role what we have just created in AWS. Also, the location where you want to from where you want to pull the file. So storage AWS ARN is going to be one. So let's go back to our AWS under IAM. Whatever newly created role what you have here, you should be able to see an ARN over here. So just simply click on this one. It will copy the ARN, come back to Snowflake and update this particular value, which is going to be the ARN. Okay, so this is the ARN. Now under the storage allowed location, you need to provide the location of your S3 bucket. So if you see, this is my bucket name, DE Academy Training Bucket. So I'll just copy this, come back here, and I will just update this bucket name over here, which is the same one what I already have. Okay, so the syntax is going to be S3 colon slash slash and your bucket name slash. So this is the location from where you are accessing the file. So once you provide all this information, just run this SQL statement. It is going to create your storage integration. Now your storage integration is created. Now we need to set up a trust between this Snowflake account and our AWS account. Until unless there is a trust, um, your Snowflake will not be able to access the file from your S3 bucket. So for that, we need to first describe the existing currently created storage integration by running a command called desc integration and name of this integration, which is s3 underscore int. So let's go ahead and create this. Once you describe this integration, you should be able to see different options over here. So from here, if you see, there are two values. One is storage AWS IAM user ARN and storage AWS external ID. These are the values which are going to be used while creating the trust between our Snowflake account and AWS account. So for that, let's go back to our AWS IAM role, and under the new role what you have created for Snowflake, you click on the trust relationship option over here. Under the trust relationship, there will be already a default policy exist over here. So we need to going to click on edit this trust policies. So just click on over here. And if you see the line number 7, there is already an IAM role present over here, which we have to remove it and update it from Snowflake. So let's first remove these values and come back to Snowflake, and I'm going to copy the value of storage AWS IAM user ARN. So just click on the property value of that and copy this particular value. Once you copy that, come back to your AWS IAM and paste that value over your in front of your AWS. Now once that is done, you need to update the external ID also. Here we have given the default external ID. So for that, let's come back to our Snowflake, and we need to copy the value of storage AWS external ID. So simply click on the property value of this one and copy this value. Come back to your AWS IAM and remove this 000 and paste this value. Now, once you update the IAM role of AWS and the external ID, click on update policy. Now your trust is built between your Snowflake and your AWS. Now, whenever a Snowflake sends a request to this particular AWS, it will automatically perform that particular operation. Now let's go back to our Snowflake. Now, once you set up the relationship, now we need to create a file format, because when we are going to load this file from our S3, this file is going to be a CSV. So this is my CSV file where I have a header also. So I want to skip this header while loading this data into my table. So all these options I'm going to create as part of my file format, which we have seen in the previous videos. When do we use the file format? So this is the syntax of creating a file format, where I'm doing a create or replace file format, name of the file format. The type is going to be CSV because I'm loading a CSV file. The field delimiter is going to be comma. The record delimiter is going to be a new line character, and I'm going to skip the first row of that particular file. So let's execute to create the file format. So my file format is also successfully created. Now I need to create an external stage uh, through which I'm going to access this file of my S3 bucket. So to create an external stage, the syntax is going to be the same: create or replace stage, and this is going to be name of my stage, which is I'm calling as my S3 stage, and I'm going to use the storage integration which I have previously created, which is S3 underscore int. So by using this storage integration, I will be able to access the S3 bucket into your AWS account, and the URL is going to be the bucket from where I am accessing that file. So it's going to be the name of the bucket. We just need to update the bucket name here according to your bucket name, and the file format is going to be the my CSV file format which I have just created. So let's create this external S3 stage. So my stage is also created. Now if I if everything is set up correctly here, if I do list at the rate my stage, where I am listing all the files present into external stage, I should be able to uh, access it. It should not throw any error. So let's execute that. Now it runs successfully. Currently, I don't have any file into my S3 bucket, so that's why it has not shown anything. But my setup is uh, correctly done, and now I should be able to access that file whenever I upload a file into my S3 bucket. So now let's go ahead and download this particular user file from our local machine to the S3 bucket. So for that, let's go back to AWS S3 bucket and click on upload. Click on add files and select the file which is the user file I'm trying to upload, and once you select that, click on upload. Now my file is successfully uploaded over here. Now, when I come back to Snowflake and I do the list at the rate my S3 stage, I should be able to see that particular file over here. So now this is the file under the S3 bucket. This is the bucket name. I have this file called user.csv. This is the size. This is the MD5 of that file. Now I can see the file from my Snowflake, which is present into my S3 bucket. Now I have to load this file into the user table, which I have created over here. So for that, I am going to use the copy command. So what I'm doing is copy into the user table from this stage where I have the file, which is nothing but the S3 location. And then I'm using the file format, the my CSV file format, which I have created over here, right? Now, once you write the SQL statement, just execute that. So now your copy command should be able to successfully load 5 records, which is present in the file into your table. So you can verify by running the select star from that user table, and you should be able to see these 5 records, which is present into your file over here. So this is how we are going to use the external stage in Snowflake to access different data files setting into our external cloud storage. In this case, we have used AWS S3, but the similar approach can be applied to GCP bucket or Azure Blob Storage also. By creating a storage integrations and then external stage file format, and by using the copy command, we should be able to access that file from those stages and should be able to load into a table inside the Snowflake. Hello and welcome to D Academy. So in the previous video, we have seen how do we perform the bulk data load by using the copy command in Snowflake from our external cloud storage such as AWS S3 using an external stage in Snowflake. That particular process is used when you want to perform a data load as at a specific time in a day into your Snowflake, such as a batch processing. Now let's say there is a data which is getting generated on a real-time basis, such as the data coming from a website or an application, which you want to ingest as soon as the data gets generated and loaded into your external cloud storage, such as AWS S3. In that case, we will use the continuous data loading approach in Snowflake by using Snowpipe. So in this video, we are going to see how do we set up the Snowpipe and then how do we auto ingest the same data which is going to land into your S3 bucket to our Snowflake table. So this is the architecture through which the Snowpipe works in Snowflake. First, you will have a data file which is being written to your Snowflake stage, which is built on top of your S3 bucket. So once you have the data into an S3 bucket, there is a notification which S3 will send to a ingestion queue, which is being created for a pipe, which would be into Amazon SQS event. And through that event, the pipe will get to know that there is a file which has been loaded to your S3 bucket, and it will run a copy command in an auto ingest mode, and that data will be loaded into a table. So let's see how do we perform this particular operation of setting Snowpipe in Snowflake, and by using that Snowpipe, we are going to load some event data into our Snowflake table. So for this activity, we are going to use some kind of a event data which will be into a JSON format. So I currently have a 3 event where I have the values such as type, message ID, message, and the timestamp. Okay, so I have 3 events which I'm going to upload one after another in my S3 bucket. And by using the pipe, I will auto ingest these data into a Snowflake. So to set up the Snowpipe, let's log into Snowflake. Uh, Along with that, we also need our AWS account because we have to upload these files into our S3 bucket. And also we want to use the IAM role to set up the trust and the authentication between our Snowflake and AWS. So let's log in first into our Snowflake account. Open the previous worksheet if you have already, or create a new worksheet which is of SQL type. Once you are in the SQL worksheet, what you have to do is like first you need to set up your role, warehouses, and schema where you want to create these pipes and everything. So first I'm going to set up my role as account admin by using the command called use role. Also, I'm going to set up my warehouse by using the SQL command of use warehouse. And also I'm going to set up my schema as mydb.myschema. So once all these are set up, uh, first I need to create an event table. And since the data what I am getting from my S3 bucket is of JSON format, I need to create a table with a column having a data type of variant, which is going to store these JSON file inside a table. So any unstructured data, if you want to store into Snowflake, you have to have the table having a column called with the data type of variant. There only you will be able to save any unstructured data. So let's create this event table under the my schema. So my table is successfully created. Now to set up the Snowpipe also we are going to create the storage integration and external stage what we have done in the previous videos, because in Snowpipe also you are going to run a copy command which is going to pull the data from external stage through storage integrations. But in Snowpipe, the ingestion will happen automatically in the bulk loading process. In the previous video, whenever you upload a file, you have to come back and manually run the copy command. But in this case, the Snowpipe will keep on running. As soon as you upload a file into an S3 bucket, it will automatically auto ingest that file into your table. So there is no manual process of running the copy command in Snowflake. So first we need to set up the S3 bucket and our IAM roles in AWS. So let's log into your our AWS account, and on the search bar, search for S3. uh, Click on the S3 option to open it. If you already have a bucket, let's use that bucket. If you don't, if you're creating a new bucket, then you can click on create new bucket and create your own bucket. But we will use the same bucket what we have used in the previous video. So this is the video this is the bucket which I have used in the previous video while setting up the bulk load process in Snowflake. So once you are inside the bucket, what I'm going to do, I'm going to create a folder which is going to be the name of event where I'm going to upload these event files. So to create a folder, let's click on create folder over here, and let's give a name as event to this folder. Once you give the name, folder name, click on create folder, and it is going to create an event folder inside your bucket. So this is the location from where we are going to upload the file and access these files through external stage in Snowflake. So now your bucket is set up. Now we need to create our Snowpipe role, which is going to have access to access this particular S3 bucket and send the data to back to Snowflake. So for that, let's open in the search bar, search for IAM. And once you see an option of IAM, just click that to open it. Once you are in the IAM page, go to the roles section on the left hand side, click on roles, and we need to create a new role. So to create a new role, simply click on create role over here. And under the trust entity type, we need to select the AWS account. And also we need to check this option as required external ID, because this is the best practice when third party will going to assume this role, because since Snowflake is a third party application what we are using, and Snowflake is going to use this role to access our S3 bucket and the file inside that S3 bucket. So we need to provide the external ID. So let's click that. And as of now, let's provide a default value of 000 and external ID. We will update it once we create our storage integration in Snowflake. So once you fill all this information, click on next. Under the add permissions, we need to attach a policy which is going to be used by this role to access S3. So since this role is going to only use to access S3, we should have an S3 access. So in the search bar, search for S3 full access, and you should be able to see a default policy already created, which is of the name of Amazon S3 full access. So let's select this policy and click on next. Now we need to provide a name of this role. So I'm going to call this as Snowpipe role. And if you want to provide a description, go ahead and provide a description. Just validate that your trust policy is there and you have under permission, you have Amazon S3 full access. Once everything is verified, just click on create role. Now, once AWS creates your role successfully, just search for that role and you should be able to see your role over here. So just open that. Now your S3 bucket setup is done, uh, where you have created a folder called event, and also your role is being set up, which is going to use to access this S3 bucket. Now let's go back to our Snowflake. And after creating the table, we need to create a storage integration, which is going to be used to access the AWS account. So here, the syntax of creating a storage integration is create or replace storage integration. I'm going to call this integration as S3 Snowpipe integration. The type is going to be external stage. The storage provider is S3. It's enabled, which is true. And here we need to provide the AWS role ARN and storage allowed location from where we are accessing the file. So storage AWS role ARN is going to be the role of the currently created Snowpipe role. So let's go back to AWS. Under Snowpipe, you should be able to see a option of ARN over here. So just click this to copy it. Once you could copy that value, come back to your Snowflake and update this value to that particular ARN. Now, under storage allowed location, we need to provide the location of S3 from where we are trying to access the file. So let's go back to our S3, and under your bucket, you click on the folder what you have created, which is the event folder, and click on copy S3 URI. So this is going to copy the URI of this particular bucket along with this folder. And so click that, come back to your Snowflake, and let's update this storage allowed location with that value. So you have S3 colon slash slash your bucket name slash your folder name slash. So this is the location where any file what you upload will be automatically auto ingest by Snowflake. So let's execute this particular command to create your storage integration. So now my storage integration is successfully created. Now, once my storage integration is created, I need to set up a relationship between my Snowflake account and my AWS account, because until unless a trust relationship is built, my Snowflake will not be able to access the AWS account. So for that, we need to describe the integration which we have just created, which is S3 Snowpipe integration. So let's execute this command called describe DESC integration S3 Snowpipe integration. This is going to describe all the different values what we have into integration. So under that, we are focusing on these two values. One is storage AWS IAM user ARN, and another one is the storage AWS external ID. So these are the two values which we have to take it from here and update into our AWS account IAM role, which we have just created. So now let's go back to our IAM, and under the Snowpipe role, we should be able to see an option called trust relationship. So just click that, and here you will already will have a default policy present. So now we need to update this policy with those values from our Snowflake account. So click on edit trust policy, and on in front of line number 7, you should be able to see a default IAM role given over here. So just remove this and come back to your Snowflake, and you're going to copy the value of storage AWS IAM user ARN. So click on this property value and copy this value which is exist here. Come back to your AWS and update these values over here. Now we need to also update the external ID. So let's remove whatever is given as default, come back to our Snowflake and copy the value of storage AWS external ID. So this is the value. Just click on that and click to copy. So your value is copied. Come back to your AWS and paste that value over here. Now you have updated the IAM role of Snowflake and you have updated the external ID of Snowflake in your AWS IAM role trust policy. So with this, you are going to build a trust between your Snowflake and AWS. So now click on update policy. Now your trust entity is updated with the details from Snowflake. Now let's go back to our Snowflake account. And since we are loading the JSON file into our Snowflake table, so we need to create a file format which is going to have a type of JSON. So this is a create or replace file format. The name of the file format is my JSON format, and the type I'm going to define as JSON. So let's create the file format first, which will be used to load the JSON file from our S3 buckets. So now your file format is successfully created. Now we need to create an external stage. This is the stage through which we will access the data from our S3 bucket in Snowflake. So to create an external stage, the syntax is create or replace stage, and my stage name is my S3 Snowpipe stage. I'm going to use the storage integration what I have created, which is S3 Snowpipe integration. The URL is going to be the bucket from where I am going to access those file, and the file format is going to be my JSON format. So let's create this external stage. Now my external stage is successfully created. Now, once everything is set up, we want to see that whether the integration is done successfully from Snowflake to AWS or not. For that, what I'm going to do is I'm going to run a command called list my stage, which is nothing but my S3 Snowpipe stage. If all the process is done correctly, I should be able to execute without any error. So let's execute this one. So now you see there is no error. Since I don't have any file inside my bucket, I am not able to see any file over here. So that's the integration is done successfully. Now everything is set up correctly. Now we need to create a Snowpipe, uh, which is going to use to auto ingest the file from my AWS S3 bucket. So to create a pipe, the syntax is create or replace pipe. The name of the pipe is S3 pipe. And here I'm going to set up the auto ingest is equal to true, which is going to help in auto ingesting the files from S3 bucket. And I'm going to run the same copy command what I have done in the previous video, where I'm doing a copy into the table from the stage, which is the stage which I've created on top of my S3 bucket. And the file format, I'm going to define my JSON file format because I'm going to load a JSON format inside my table. So let's execute this one. Now my pipe is successfully created. So to check the status of this file, this pipe, we can run a command called select system dollar pipe status and the name of the pipe what I have created, which is going to show the status, what is the current status of this pipe. So let's execute this one, and you should be able to see that your pipe is in the running phase here. Execution state is running. Now, once we create the pipe, we need to set up a event notification in our S3 bucket from where the pipe is going to get a notification whenever we upload a new file. So to get the notification channel, what we have to do, we have to run a command called show pipes, and this is going to give us the notification channel, which we're going to use that and put into our S3 bucket while creating the event notification. So let's execute this show pipes, and this is going to give all the information related to your pipe. And if you scroll on the right side, you should be able to see there is a notification channel where we have a ARN of AWS SQS. So if you see in this example here, uh, this is the notification channel. What is this ingestion queue, which is nothing but your SQS queue. Okay, so whenever you upload a file into an S3 bucket, the S3 will send a notification to this ingestion queue, and from here the pipe will automatically picks that data and load into table. So this is the location of that SQS notification channel. So now let's go back to our S3, and under the S3 we need to create an event notification. So let's go back to our bucket, and under the bucket you click on the properties tab here, and if you scroll down you should be able to see an option called event notification. So here we need to create this event notification. So to create a new event notification, just click on create event notification. Under the general configuration, we need to provide a name of this event. So I'm going to call this event as Snowpipe. Under the prefix, we need to provide the folder location from where we want to set up this event notification, because this event, if you don't provide this folder, it will create at the bucket level. because since under the bucket we have a folder, we want to create this notification from that particular folder. So uh, we need to provide this as from event. Once we have this over here, in the suffix we can leave it. In the under the event type, we want to generate an event whenever we create a new object inside a S3 bucket. So whenever we are putting any object, we are posting any object, copying any object, or uploading any object, it should create an event into your S3. So let's select all created event. Now, if you scroll down, keep everything as default. Scroll down, you will see a destination folder over here. So under the destination, um, it is going to ask you from to where you want to send this event notification. So we want to send this to an SQS queue because that's the queue what we have into our Snowpipe. So select the SQS queue and it will ask you to provide the SQS queue. We want to provide an ARN because that's the ARN what we have in the pipe. So click on enter SQS queue ARN and come back to Snowflake and copy the value under the notification channel, which is this particular value. Just click into copy, come back to your AWS and paste it that value over here. So now and click on save changes. Once you click on save changes, you should be able to see that your event notification is created where the event is created on this particular folder inside the bucket, and the destination is the SQS queue which is present into your Snowpipe. So this is the location where the event will go, saying letting the Snowpipe know that there is a file on S3 bucket, and it will auto ingest that file automatically. You don't have to manually run it. Now all the setup of Snowpipe is done. Now we need to upload the file to see whether the pipe will automatically load the data into our table or not. So let's come back to our Snowflake. And if I do a select star on the event table, I should be able to see a zero record in the table because we have not uploaded any file into an S3 bucket. Now let's go ahead and upload the first event file what we have. So come back to your S3 bucket under the objects, open your bucket, and first let's create the event1 file. So upload the file here, click on add files and select the event1 file. So this is the JSON file for the first event which I'm uploading, and click on upload. Now your file is successfully uploaded into your S3 bucket under this particular folder called event. Now let's wait for a few seconds because the pipe will buffer every 30 seconds to check whether there is a new notification into my queue or not. Over here, every 30 seconds it's buffer into this queue. If there is a new notification, it will pick that file from an S3 bucket. So let's wait for that, and let's execute this particular command, select star from event, to see if my data is successfully loaded into my table or not. So now you see the event which we have uploaded is this event one. So where I've have the message ID as 123 and the message is alert. So if you see the table, I have this message ID as 123 and message is alert. So now my Snowpipe has successfully loaded the data from this event what we have uploaded automatically into my table. Now let's go ahead and upload the other two events what we have and see how if the pipes load is those files or not. So let's add those file, and in this time I'm going to select both the two events simultaneously. So event 2 and event 3 and upload these ones. And once your file is successfully uploaded, you should be able to see those two files into your S3 bucket. And let's wait for 30 seconds to see if your pipe automatically picks both these events and load to your table or not. So let's go ahead and try to run a select star. So now till now I think it has not loaded. So let's wait for a few seconds to see if the pipe picks those events automatically and load into your table. So now you see after a few seconds the pipe has automatically loaded your event 2, which is of 456, So if you come back and check the event 2, the message ID is 456. And if you check the event 3, the message ID is 789. So if you come back and you see the message ID is 456 and 789. So this is how you can use a pipe to auto ingest your file into from your S3 location to your table inside in Snowflake. So I have done nothing. I have set up just all these setup into my Snowflake, and I'm just uploading the files into my S3 bucket, and automatically the Snowpipe is picking those files and loading into Snowflake. So this is how we can automate a real-time ingestion inside in Snowflake. Uh, if you come back and see this example, so whenever some streaming platforms such as Kafka and Firehose is writing the data to your external stage, cloud storage, which is nothing but your AWS S3. The S3 is automatically sending a notification to your Snowpipe service, and that is going to auto ingest those files from your S3 location to your table inside the Snowflake. So this is how you create a Snowpipe inside uh, Snowflake, and then perform the auto ingestion of the file from your external cloud storage. Hello and welcome to the Academy. So in this video, we are going to talk about what are streams in Snowflake. Snowflake streams are objects that tracks all the DML operation against any source table. Uh, Under the hood, Snowflake streams add three new columns, which is nothing but the metadata columns called metadata action, metadata is update, and metadata row ID to the source table whenever we create a stream on top of that particular source table. These additional columns allows the stream to capture information about any inserts, updates, or deletes without having to store all the data, all the table data inside the stream. Uh, this the Snowflake stream can be created on the following objects, such as you can create a stream on top of a standard table, a directory table, an external table. Even you can create a stream on top of views also. Some of the objects in Snowflake on which you cannot create a streams are your materialized view or any secured view, such as your secure views, secure objects such as secure views or secure user defined function. On that you cannot create any streams. Now we talked about the three new columns what the streams create when you create a stream on top of your source table. So these are the three additional columns which contains the metadata of each of the records. So the first column is a metadata action, which is going to indicate any DL operation such as insert, delete, or update, which is happening on any particular row inside your source table. Metadata is update, tracks update as delete plus insert. So this column is going to contain whether you have this will contain a boolean information of true and false. If you have an update on top of your records, this column is going to store a value of true. If it does not have any update on your source table on that particular row, then it is going to contain a false in your stream table. The third one is the metadata row ID. So for each of the unique records, which for each of the records what you insert into your source table, the streams generate a row ID for that particular record. So based on that row ID, it captures, it tracks the changes happen on that particular column inside your source table. So these are the three additional columns what streams added when you create that on top of your source table. So if you see here, uh, so I have a source table where I have a three columns called ID, name, and create date, where it has some values. When I create a stream on top of my source table, what stream does, it also add three new columns, which is these three metadata columns inside its streams. And based on that, if you see the values, the action is insert, the is update is false, and it also generates a row ID. So since you have inserted a record inside your source table, which is nothing but ID 3, what stream is capturing that this particular record has been inserted into your source table. Uh, the action is insert. You did not have an update. That's why the condition is false, and it has generated a row ID against that particular row. Now let's say different types of streams we have in Snowflake. So currently uh, it has three flavors of stream to match different needs of data capturing inside a Snowflake. The first we call as a standard stream. Uh, as the name suggests, it tracks all the modification happen to your source table, including any updates, any inserts, or any deletes happens on your source table. So if you need uh, any pipeline where you want to capture the full changes, full data, change data capture, then you could deploy a standard stream on top of your source table. The second one is the append only streams. So these type of Snowflake streams strictly record new rows added to the table. So just insert, right? Updates and delete operations or including the table truncates also will not be recorded through append only streams. Append only streams are only useful when you just need to see new data as it arrives. The third one is the insert only stream. So insert only streams are supported only on the external table. So as you mentioned, as you know, the external tables are the tables which you create on Snowflake, but they can reference the data from an external cloud storage. So if you have that kind of tables inside a Snowflake and you want to track the inserts happening on those particular external tables, so then you can create a insert only stream on top of that particular table. They don't record any delete operations that remove rows from the actual data sources. So these are the different types of streams what currently we have in Snowflake. So now let's go ahead and see these streams in Snowflake. How do we create it and how do we track these changes? So for that, let's log into your Snowflake account, and under the projects you open already existing SQL worksheet, or if you don't have any, just click on plus sign and open a SQL worksheet. So I already have a worksheet, so I'm going to open that. So uh, for this particular hands-on, first I need to going to set up the roles, warehouses, and database where I want to create these streams and tables. So I'm going to execute where my role is going to be account admin, my warehouse is going to be compute warehouse, and the schema where I am going to create all the tables and streams are going to be my DB and my schema. Now, first, we are going to see the standard stream where you will track all the change data captures, whether you are inserting a new record in your source table, updating a record, or deleting any record. This particular stream will capture all the changes. So let's see that. So for that, I'm going to create a source table where I have these columns called ID, name, and create date. So let's create this table first. Once you create this table, I'm going to insert few records inside this particular table. So I've inserted this. Now, if I do a select star on this table, what I see, I can see these two records over here. So that these are the records which is currently exist into my source table. Now, what I'm going to do, I'm going to create a standard stream. So the syntax of creating a stream, standard stream is pretty straightforward. Create or replace a stream, name of the stream, and on which table you want to create this. So I'm going to create this stream on my source table one. So that's why I've written that on table source table one. So let's execute this command to create our stream. My standard stream is successfully created. Now, if I see the data into my source table, I have two records. But if I see the data into my standard table, a standard stream, I don't have any record as of now because I have not inserted or deleted or updated any record as of now post creation of the stream. So now going forward, whatever operations I do into my source table, this stream is going to capture all those records inside it. And if you see it along with the three columns what I have in the source table, it also added three new columns which we have talked about, the metadata columns. The metadata action is update or row ID. So now let's do some sort of operations, DML operation on our source table. So first, what I'm going to do is I'm going to insert a new record inside my source table where the ID is going to be the 3. So let's insert this record over here. Now, as soon as we insert this record, the stream is going to capture this operation saying that there is an insert happen into my table, and what is that record is going to be the ID number 3. So now let's see the data into my source table. So if you can see the data into source table, you will have three records. One, which you have insert the two records, the ID number 1 and 2 was already there into source table before creating the stream. Now, after creating the stream on this particular table, what I have done, I have just inserted a new record, which is the ID number 3. Now, this is my source table. Now, let's see what is the data you have in the stream. So if you run this select star, you should be able to see that stream has only captured the ID number 3 because this is the new record. This is the new DML operation what you have done on the source table post creating the stream. And if you see the action, the metadata action is insert metadata is update is false because you have inserted, you have not updated that record, and it has generated a row ID for this particular record, which is ID number 3. So this is how the stream is going to capture any change. In your source table, you have 3 records, but we have done a DML operation on only one record post creation of the stream on our table. So the stream has only captured that particular record. Now let's do some more operation on this one, where what I'm going to do is I'm going to delete the data where the ID is equal to 2 from my source table. So let's run this particular statement. So now you have deleted that record from your source table. Now, if you do a select star on your source table, you should be able to see only 2 records where you have deleted the ID is equal to 2. Now, if you go back and query your stream, you should be able to see the record number 2 also here, meaning that there was a DML operation happen onto your source table where the action was delete, and that action happened on ID number 2. Okay, so the stream is able to capture that, okay, there was already a ID number 2 into my source table. Now since I have deleted that ID is not into the source table, but the stream has captured that what is the action what you have performed on that particular ID, which is the delete operation. Okay, now let's go ahead, and in the next operation, DML operation, we are going to do an update. So what I'm doing is I have an ID column, ID is equal to 1 inside my source table, where for that particular ID, the name is currently uh, Chaos, right? And what I'm doing is I'm updating that name to Alan. Okay, so let's execute this update statement over here. So now your record is updated into your source table. So if you go back and check your source table, you should have an updated name for the ID 1, right? So your name is now Ellen uh, compared to what you have previously in your source table. Now let's check the stream, how the stream has captured this particular DML operation. So now if you see here, if I just order by this on ID1, what it has done previously, so in the streams, the updates happen in form of insert plus delete, right? It does not say that, okay, it only tells us with the flag called true that on this particular record you had an update happen. Okay, so what stream has captured that previously you had ID1 where the name was Chaos, right? That particular record has been deleted, and then what you have done is you have just inserted a new record with the new name for ID number 1, right? So this is how the streams capture these DML operations inside your Snowflake. Okay, and if you see for ID1, the row ID is same, right? So based on this particular row ID, it is going to track all the changes happen on a particular ID column. Okay, so this is the standard streams which is going to track all the different DML operation inside your source table. Okay, now let's see the next set of next data stream, which is only the append only. So in the append only, it is going to capture only the new records which you have just inserted, right? It is not going to do capture any any other DML operations such as updates or deletes what you do onto your source data. So for that, let's create a table which I'm going to call as source table 2. And what I'm going to do, I'm going to insert a few records into this source table. Now, to create an append only stream, the syntax is going to be the same. So we have create or replace stream, the name of the stream, which I'm going to call as append only stream, on table, which table I'm creating on this source table 2. And you need to add a prefix saying that append only is equal to true. So if you have this prefix, what Snowflake does, it only creates an append only streams in your Snowflake table, right? So let's execute this stream. Now, if you run the select star on this stream, you should be able to see the same structure what you have seen in the standard streams, right? You have the columns coming from your source table, which is ID, name, and create date, but you have 3 extra columns called action, update, and row ID for the metadata. Now, let's insert some data into this particular source table. So I'm going to insert an ID 3. So let's execute this. So now my data is inserted. Now, if you do a select star on your source table, what it does, it will show you three records, right? Uh, but if you do a select star on your append only stream, it is going to only show one record, which is the ID 3, which you have added in your source table post creating your append only stream. So that's how the stream has captured that there is a new record inserted into your source table. Now, if I update data inside this table, where I'm going to update the ID, the name of the ID1 from Chaos to Alan, this particular data stream will not capture this DML operation because this is only for append only, right? So if I do a select star on my source table, I could see that my name of ID1 has updated from Chaos to Alan, right? But if I go and do a select star on my append only stream, it is not going to capture that particular DML operation, right? Because this is only going to capture where the action is going to be insert. It does not capture any deletes or any updates happen on your source table. So this is specifically when you are only focusing on capturing any new record inserted into your source table, right? This could be deployed on a source table where you are storing an event data, right? You don't want to focus on any records where the updates happen on an event. You only focus on anything which is coming as a new inside your source table. Now let's see how do we use this stream in your ETL process, right? So till now we have seen that how the streams capture all the changes happen on your source table, right? But how do we use the this particular stream while creating a data pipeline into your Snowflake, right? So let's say this is a source table two from where my source pipeline is writing the data, right? And from here, I want to move this data to a target table where everybody is trying to access the data. So for that, let's create a target table. So I'm going to give the same structure what we have for my source table. Okay. Currently, if you see in my append only stream, I have one record, which is nothing but your ID is equal to 3. Okay. So and your target table is empty because you have just created that. So you don't have any data. Now, if you want to uh, move this data right from your source table to your target table, what you can do, you can run an insert statement on your target table where what you are doing is selecting the ID, name, and create date from your append only stream. So rather than going back to your source table to populate your target table, what you can do, you can write that insert statement on top of your stream, right? So any updates happen into your source table will be captured by stream, and then from that stream you should be able to move the data to your target table. So let's execute this one. So what it does, it is going to insert that one record, which is the ID is equal to 3. So if you select the data from your target table, you should be able to see an ID 3 over here. But when you go back to your stream, right, and you select it, you should not be able to see any records now, because since there is a DML operation happen on your stream where you have accessed the data out of a stream and put it into your table, right? So the data has now moved from streams to your target table, right? So any DML operation what you do on top of your stream, the data will be moved, right? Because uh, if the data will still in the stream, next time when you are running this insert statement, it might insert a duplicate data into your table, right? So every time when you move the data from a stream to a target table, the data from the stream will be empty. Okay. Now let's see if I insert a new record into my source table where I'm going to insert an ID 4. Okay. So let's insert this data over here. And if you go and check the data into your source table, you should be able to see 4 records over here, right? Because we have just inserted a new record of ID 4. Okay. But if you select the append only stream, here you should be able to see only one record, right? So your source have 4 records, right? But since you have only inserted one record into your source table, the stream has only captured that particular DML operation, right? Saying that, okay, this is the data what is newly inserted into a table, my source table, and this is the data which I have to move to my target table also, right? So the stream is also going to help you in terms of, let's say if you have millions of data sitting in your source table and the update is only happening on, let's say, thousand of records, right? So rather than and if your inserts insert query is running on your source table, what that is going to do is going to scan the entire table and understand that there is only change happen into 100 records out of those millions of records, right? But if you use a stream, what a stream is going to do, uh, that it is going to capture only those 100 records out of those millions records from your source table, because only in those 100 records you have a change, right? When you're running an insert on your target table from a stream, that means your queries are going to run faster, because it is only going to run on those 100 records, right? Compared to the previous query, where if you're running the insert of your target table from your source table, that insert is going to scan the entire millions of record, and then from there it is going to identify those 100 records which has a change, right? So by using the stream, you can perform your queries faster also, right? So now your stream has only one record. Now what you can do is you can just run an insert statement in your target table from your append only stream. So if you run this particular statement, this insert is going to take that one record from stream and insert into your target table. Now once the data is inserted in your target table, your data will be gone from your stream, and you will have an empty stream. Okay. Now again, if you select the data from your target table, you should be able to see that ID1 has been inserted to your target table, right? So this is how you can use append only or in your data pipeline. Now the next one is the insert only stream. So insert only is only being created on top of your external tables, and it is only going to track any new rows insert, like similar to append only. It is only going to track any newly inserted records, right? But insert only stream is only we are only able to create this one on top of your external table. So the syntax of creating an external stream is the same: create or replace a stream, the name of the stream on, you need to specify that this is going to be created on top of external table, right? The previous one, we were only mentioning on table the table name, but in terms of your insert only stream, you need to mention that this is going to be created on external table, and then you have to specify that insert only is equal to true, right? So by this SQL statement, you can create an external insert only stream on your external table, right? So this is how we create different streams inside a Snowflake. And by using those streams, you can perform the change data captures on your source table to perform any ETL operation inside your Snowflake. Hello and welcome to D Academy. So in this video, we are going to talk about the tasks in Snowflake. Snowflake tasks let you run a SQL query on a schedule. Um, so if you want to run a SQL queries on a schedule, you can use the functionality of task in Snowflake. And the SQL command can be of anything. You can execute a single SQL statement, or you can call a store procedure, which is nothing but a combination of multiple SQL statements. Similar to other Snowflake objects, the task can be created and managed programmatically with the SQL. So you can create task with a SQL statement. Uh, these are the four most common parameters we have to use when we are creating a new task. The first, it needs to have a schedule, that when should your task trigger. It also should have a warehouse, that what compute cluster should be used, right? In the task you are running a SQL queries, and SQL queries on Snowflake runs on a warehouse, so you have to mention a warehouse while creating a task. The third one is that you need to have a SQL command to run. This could be a single SQL statement, or you could have a store procedure where you can club multiple SQL statement if you want to run as part of your task. The fourth one is a condition, that it's a Boolean expression that gets evaluated when the task is triggered, right? So it determines whether the task will be executed or skipped if the condition is not met. So this is an optional, you can give it, but it's good to have a condition so that your task is not running unnecessary. You always have an expression to check that whether the condition what I have given in task has came as true or not, and then you execute the task. execute the SQL statement inside that task, else the task will skipped. Now, what are different types of tasks we have in Snowflake? So currently we have two types of task. One is the user managed task. In the user managed Snowflake task, you have to manage your compute resources for individual task by specifying a existing virtual warehouse when creating a task. So if you see the statement over here, this is the statement to create a task in Snowflake. So over here, what we are doing is we are specifying an existing warehouse while creating this task, that whenever this task is going to run, it is going to run on this compute underscore warehouse. So this is, and these all warehouses are user managed, that somebody in your organization might have created that warehouse. So this task is going to run on this compute warehouse. The second one is the serverless Snowflake task. It is going to help you rely on compute resources managed by Snowflake instead of the user managed warehouse. So in this case, the warehouse is going to be managed by Snowflake. Initially, what you have to define is you have to define a size of a warehouse, that when the task gets triggered, it has to trigger on a warehouse which is going to be extra small warehouse. If Snowflake understand that, okay, this particular task or the SQL statement what you're running into this task is not going to get completed, or it's taking too much time to execute on a extra small warehouse, what Snowflake internally does, it moves this task to a larger warehouse, which could be a small warehouse or a medium warehouse or a large warehouse based on the complexity of that SQL queries what you are running. So it works as a serverless, right? As your compute requirement increases, the Snowflake increase the size of the warehouse on which this task is running. So this is the serverless Snowflake task. Now, how do you schedule a task in Snowflake? So currently, since the task is not an event based, you need to run the task on a schedule. So there are two approach through which you can schedule a task. One either with a cron expression, or another with a non-cron expression. So in the non-cron expression, you can provide your schedules like either in minutes, hours, or days, right? A minimum you can go is like 1 minute. 1 minute is the minimum schedule what you can give a task, right? So if your schedule is hard coded that it's going to run every 1 minute, 5 minutes, 10 minutes, or 1 hour or 2 hours, then that's a non-cron expression. In the cron expression, then if you want to run your task at a specific time in a day or on a week, then you can use a cron expression over here, right? So if your schedule is using a cron expression, then that is a cron notation through which you can schedule a task. So now let's see in Snowflake, how do we create a task, and when this task is we use this task in Snowflake. So let's go back to our Snowflake and log into your Snowflake. Once you are in a Snowflake UI, let's go to your worksheet. And if you already have a worksheet open, just open it, or you can open a new SQL worksheet over here. So I already have a worksheet, so I'm going to open that. Now, as we have did in all the previous video, first we are going to set up the context of role, warehouses, and database, which we are going to use as part of this particular video. So I'm going to set up my role as account admin, my warehouse as compute warehouse, and my schema is my DB my schema. So once everything is set up, now let's say, how do we typically run our SQL statement without a task in Snowflake, right? So for that, let's say I have a source table where I have these columns, ID, name, and created date. So let's create this table first. So this is my source table. Now I'm going to insert some records into this source table. So I'm going to insert two records, ID1 and ID2. Now let's see the data into source table. So now I have a ID1 and ID2 inserted into my source table. Now what I have a target table where I want to insert the data from my source table. So whatever three columns which I am getting from my source table, I'm going to insert as it is. But what I'm doing is I am also creating three new columns, which is nothing but a created date, created month, and created year, which I'm going to extract from this created date column. So these are the three extra column which I am planning to add into my target table. So let's create the target table first by running the create or replace table command. So my target table is completed. Now, if you want to load this data from my source table to the target table, what I have to do is like I have to run this insert statement manually, right? So what I'm doing is like inserting into the target table, selecting all the data from my source table, and extracting these three new fields from my created date. So I'm extracting day, month, and year, right? So this is a manual process. So if I execute this insert statement, the two records what I had in the source table, it gets loaded into my target table. So let's check that into my target table. And I should be able to see ID1 and 2 here. And these three new columns, what I have extracted as part of my SQL statement. So this insert statement, what I have done is I have executed manually. Now let's say if I insert a new record into my source table, right? Uh, or some process is inserting some records into my source table. Let's say you are using a copy command or a snow pipe, which is inserting this data into your source table. Now this data is now available into your source table. So if I execute select star from source table, I should be able to see this newly inserted record, right? But I will not have this data into my target table until and unless I will execute my insert statement. So this is my target table. I don't have that ID3, but until and unless I am executing this insert statement, that ID number 3 is not going to get inserted into my target table. So let's execute that. So once I execute and go and check my target table, I will have my ID3 inserted over here. So this is all manually I am doing here, where there is no schedule when the SQL statement is going to run. As soon as Snowpipe loads, let's say Snowpipe loads this data into my source table, which is going to be get automated. If I want to move this target table, I don't have any automated way where I can run the SQL statement, right? Uh, in this play, so for this particular use case, the task is going to come in handy in Snowflake, right? So whatever manual inserts what you're doing in a target table, that can be automated by using a task inside a Snowflake. So let's see the same scenario here. In the next scenario, in place of inserting this data into target table manually, what we are going to do is like we are going to put this SQL statement inside a task and then see how this task works in Snowflake. So now let's go ahead and follow the same approach. I will create or replace the same source table here, and then I'm going to insert the same records, the two records into my source table. Okay, so if I execute my select star from table, I should be able to see these two records. Okay, now I'm going to recreate my target table again, where I will have the three extra fields, which is created date, created month, and created year. So let's execute this to create our target table. Our target table is completed. Now, after that, if I have to insert this the data from source table to target table, what I'm doing is I'm running the same insert statement, right? But at this point of time, what I'm doing, I'm just putting this insert statement as part of my task, right? So the syntax of creating a task is create or replace task, the name of the task. Uh, I'm going to provide a warehouse, which is the compute warehouse on which this task is going to execute this SQL query. And then I'm going to put a schedule as 1 minute. So every 1 minute, this task is going to run automatically. And if I have any data inserted into my source table, it is going to pick that data and insert into my target table. So let's create this task first. So my task is created. Now, whenever you create a task in Snowflake for the first time, the default it creates in a suspended mode, right? Your task does not run. So to check all the tasks inside a schema, you just need to run a show tasks command, and it will be able to show all the different tasks what you have inside your schema. So I currently have this task my underscore task, and if you scroll on the right hand side, you should be able to see this particular task is in a suspended mode, right? So we need to resume this task, or you need to start this task so that it will run every 1 minute, because the schedule what we have set up is every 1 minute. So to do that, what we have to do is like we have to alter the task by running this command alter task, the task name, and we have to do resume. So let's run this particular one, um, and let's see. So once you execute that, if you rerun again this show underscore task, you should be able to see the status of your task, which is this my underscore task. And if you scroll on the right hand side, the state is going to show as started. Okay, so now your task is running, which is going to run every 1 minute. Now, if you want to see the status of your task, this is the command where you can check the status. So under this information schema, there is a task history table, which is going to contain all the different tasks what you have, right? So I'm going to check the status of task, which is my underscore task. So if I execute this particular command, I should be able to see one row where it is showing that your task is currently in the schedule phase, because the schedule time has not come, right? The schedule time is 7:49, right? And it also show that what is the next schedule times, right? So current schedule is it is going to run at 7:49, and next time it is going to run at 7:50, because the schedule we have set up as every 1 minute, right? And if you check the target table, probably your target table also will have empty, right? But now you could able to see your data into target table. That means your task has successfully executed. Now let's go back and run the same status again. This time you should be able to see two records over here. One, the previous instance of your task is succeeded, right? Which has executed at 7:49. The query started at 7:49. And now the next schedule of this task is going to run at 7:50 after 1 minute, right? So that means I have not run this insert statement manually, but I have put it in the task, and the task automatically run the SQL statement every 1 minute, right? Now let's go ahead and insert a new record into your source table. And let's see in the next execution, the task will automatically pick this record and insert into your target table, right? So now I have inserted one more record into my source table. And if I see this source table, I should be able to see a ID is equal to 3. Okay. So now after 1 minute, this task will automatically picks that data from source table and load into your target table. So let's see if my target table has that data or not, right? So now you see your your ID3 has been inserted into your target table successfully, right? We have not done anything. What a Snowflake had does, it has executed a task at 7:50. So if you go back and your task history, you should be able to see the second instance of that particular task, which was scheduled to run at 7:50. It started at 7:50, and next schedule is came as 7:51. So every 1 minute this task is going to run, and when the task is going to run, it is going to run this particular SQL statement where it is going to pick the data from source table and target table. So this is how you use a task, or you create a task in Snowflake. And by using this task, you can automate any execution of any SQL queries, right? Whether it's a one SQL query you want to run, you can directly put that SQL query into your task. If you want to run multiple queries one after one another, then what you have to do, you have to club all those SQL queries into a store procedure in Snowflake that we can see in the later video. You put everything into a store procedure and then call that store procedure as part of your task, right? So this task is going to automate your process in Snowflake, where if you want to move the data from one table to another table and you want to schedule those job, you can use the functionality of task in Snowflake to execute that pipeline on an automated way. Hello and welcome to D Academy. So in this video, we are going to talk about two important features of Snowflake. One is time travel and another one is fail safe. So let's first see what is time travel in Snowflake. So as we are working with the data, there will always be a problem where somebody did something by mistakes, which is not supposed to be happen. Somebody has dropped a table, or some rows are deleted, or schema has been edited in your database, right? It could be a combination of user error where somebody who is working with the data by mistakenly delete the rows or the tables from your database, or it could be a system error where your entire infrastructure is down, or by mistakenly uh, all the components what you have in that is infrastructure has been wiped out. Also, in the previous technologies before Snowflake, what we used to do is we used to take a backup of all the different objects what we have in the database, so that in the times when there is an issue with the data, we can take the data from the backups, right? But running a backup is a time consuming process, and you need to have people, specialized skill of people needs to be in the team who can do that, such as the DBAs to do that. So these are the problems when you're dealing with databases which can occur while you're working with them. Now, how do we solve these problems in Snowflake? So Snowflake has given a solution which we call as time travel. So as the word means time travel, that you have to go in a certain point of time to fetch something out of the databases, right? So the time travel can access historical data at any point within a defined retention period. So as we have discussed in the previous videos, that there is a retention concept in Snowflake which can be applicable to all the databases object inside Snowflake, right? So based on your retention period, it start from 0 days, and it in the enterprise version it goes to 90 days. So whatever retention period you have applied on those particular objects, such as tables, views, schema, or databases, you can go up to that point of time in history and bring the data if you want to, right? uh, you can do any common mistakes undo, right? So whatever common mistakes, like you have dropped a table, you can undo that operation. If you have dropped some records, you can undo that, or a schema. uh, it helps you in production against accidental or intentional modificational removal, or any corruptions happen in the data, right? It is going to fix drops, deletes, or edits in your data. Also, you can back up, you can kind of backing up the data, and from that backup you can able to restore the data again based on some time, or based on some IDs, right? So this is the solution what Snowflake provides, which we call as time travel. uh, Now, time travel can be done through two ways, and it can be applicable for all the different objects what we have in Snowflake, such as tables, schema, databases, or at the account level also you can set the retention, right? You can set the retention at a specific object, or you can set the retention at an account level of Snowflake, right? So where every object in that particular account is going to have the same retention, right? Now, how do we create a table with a time retention? So let's say you want to create a table in Snowflake. So this is the command where you are creating a create table, my table, with column called C1, right? And this is going to take a default retention what you have set up at your account level, if you don't specify a specific retention on your table, right? But if you want to customize this retention period based on your own use case, you can apply it to a particular table. So let's say if you want to create a table, my table, with the retention of 90 days. So you just need to run the same command, create table, my table, with the column name, and you want to set the data retention time in day. This is the feature what you have to set it to 90 days, right? So if you run this particular command, this particular table, my table, will create a data retention of 90 days. If you want to create a 30 days, then you have to just change the parameter from 90 to 30, and the table will create it with the 90 days, 30 days retention. So this is how you can create a table with a time travel. So if your table is created with 30 days retention, you can go up to the 30th days, and you can retrieve the data out of that, right? Beyond 30th day, you'll not be able to retrieve the data from your historical backdrop. Now, how do you query with a time travel, right? So there are two ways which Snowflake supports. One is at, and one is before, right? So from a particular table, if you want to access any historical data, what you can do at a given specific timestamp, whatever is the snapshot of your table at that point of time, you can access that particular from this particular query. Or if you want to access the data before running any SQL query, let's say you run a delete statement on your table by mistakenly, where you have deleted some IDs, right? So that's when you run that delete statement, it is going to generate a query ID for that particular SQL. Now, if you want to restore the data, and that delete statement what you have ran is by mistakenly run by you, right? And if you want to access the data before those delete statement, then what you can do, you can use a before statement here, before that particular query ID on which you have run the delete statement. You should be able to access that particular data. We will see this one into Snowflake, how we can do that. Also, you can clone the data based on these time travels. So let's say you want to access the data from my table where the data was at this particular timestamp, whatever data you had in the my table one, and you want to create a table out of that. You can just run like a command called create table and restore table, clone my table, and whatever that table data was at that point of time, it will create a clone table for you. Okay. If you want to restore any object, so there is a simple command called undrop in Snowflake. If you by mistakenly drop the table, schema, or database, you can just instantly run a undrop statement on that, and your table, schema, and database will get restored into your Snowflake, right? And that can be done within the time retention period what you have applied on these particular objects. So how does it works in Snowflake, right? As we have already talked about micro partitions, right? So the data in Snowflake stores in a concept called micro partitions, and micro partitions are immutable, right? Whenever the data is changed, a new version of micro partitions are created. It does not Snowflake does not go and update the same micro partition where the data is sitting. Let's say you have an ID1 which is sitting in micro partition P1, and that ID has a name, let's say ABC. Now, if you update that name of that ID from ABC to XYZ, the Snowflake is not going to go and update the same partition where you have ID 1 having the data ABC. It is going to create a new partition for you where you will have an ID 1 and the name will going to be XYZ. Right, so you will have both the instance of the data setting into your Snowflake. One where you have older data where the ID1 has the name ABC, and you will have a new data which has the same ID has the name XYZ, right? So both instance of the data sits in micro partitions in Snowflake up till the retentions what you have applied on that particular table. So if you want to access the older version of the data, you can go back in the time at that point of time and bring the data. If you want to access the newer version of the data, you can just do from the table itself, right? So that's why the Snowflake keeps the older version for the specific retention time applied on the table. Now let's see this time travel, how it works. So there is a table here where we have set a retention of 3 days, right? And let's say there is a data here which we have updated. So this is the older version of the data, and now we have updated, and so my Snowflake creates a new version of that data, right? So now you have the new version and you have the old version also, right? So Snowflake is going to store this older version of the data up to the 3 days period, because you have the retention applied on the table to 3, right? So you'll keep the V1 till on day one also. It is going to keep the V1 at day two also, and it is going to keep the V1 at day three. After the day three, what Snowflake does, it removes that version out of its micro partitions, right? So on the fourth day, if you are trying to access this V1 version of the data, you will not be able to, because it is outside of this retention what you have applied on your table. Now, in this case, after 3 days, is there any way where we can access this particular data, the V1 version in Snowflake, right? There comes the picture of failsafe. Okay, so failsafe is going to help you if you want to retain the data after the retention applied is over on the table, right? After 3 days, on the fourth or fifth day, if you want to access this V1 version of the data, what you can do is you have to access this data from the fail-safe option. Okay, and that has a default of 7 days. So under the fail-safe, Snowflake is going to keep your entire data set for 7 days. Okay, and this is by default for all the databases, all the objects what we have in Snowflake, right? You cannot update this one, because for this fail-safe, it's a non-configurable, and it is only accessible by Snowflake Personal. So you don't have access of fail-safe data, right? If you want to retain the data after your time travel is completed, then you have to connect with Snowflake Personal, and they are going to help you access this data out of their own storage. Okay, so uh, this is an option where you can have the failsafe applied on your Snowflake. It is not supported for any temporary or transient table. It is only supported by a permanent table. So if you have a permanent table created, and there were some issues happen with the data, and you have already crossed the data retention time in a day period, which is, let's say, 3 days. On the fourth day, if you want to access that data, you have to go back to the Snowflake team, and they should be able to help you restore that data from the failsafe option, which has the retention of 7 days, right? So this is how the data production option by edition is currently available in Snowflake. So if you see time travel of 1 day, it is present in your standard and the premium version of Snowflake edition, right? For the enterprise, business critical or VPS, the time travel goes to up to maximum of 90 days. So it start from 1 day and it goes up to 90 days. But in standard and premium, the default is 1 day. You cannot go beyond 1 day. But the fail-safe option is applicable for all the different editions of Snowflake, which is non-configurable, and the default is 7 days. So this is going to be the same for all the different editions of Snowflake. Now let's see the time travel in Snowflake. How does it works? So for that, let's log into your Snowflake account and open a new worksheet. If you have already a worksheet, just open that. Also, you can create a new worksheet. So as we have done for the previous videos, we are going to set up our role, warehouse, and a schema. So my role is going to be account admin. Okay, I'm going to set my warehouse as compute warehouse, and my schema is going to be mydb.myschema. So once I set up all these contexts, what I'm going to do is I'm going to uh, see how the time travel works when you delete some rows out of your table. Okay, for that, what I'm going to do is I'm going to create a table called drop table, which has a two columns called ID and name. So let's create this table. Okay, now my table is successfully created. If I refresh this and go back to my schema, I should be able to see this table over here, the drop underscore table. So my table is successfully created. Now let's insert some data into this table where I'm going to add these four rows where I have the ID from 1 to 4 and I have the names of those IDs. So let's insert this data into the drop table. Now the rows has been inserted successfully into my drop table. Now let's do a select star on this table to see how the data looks like. So if I do a select star, I should be able to see the four record inside my table. Now let's say somebody by mistakenly drop some record out of this particular table, right? So, there is a data engineer who's working who comes back and he just run this delete from drop table where ID is equal to 4. So he has by mistakenly deleted the data where ID is equal to 4. So let's execute that. So the row has been deleted from the table. Now if I select this data into the table, I should be able to see only row number. I don't able to see the row number 4. I only have 3 records here, right? Now if I want to restore this data, I want to see, okay, this is done by mistake by somebody, then I want to restore this data. So what happened that as we discussed, there are two ways we can do it. Either at certain timestamp, whatever the data I had in the table, I can see that, or before any statement, I want to see the data, I can do that, right? So now so this is the command through which we can do select star from the drop table at a particular offset, right? Let's say key what was the data in my table, drop table at 1 minute ago, right? Before running this delete statement, right? Because this delete statement I have run it last 30 seconds, right? So before 1 minute, what was the state of my table, the drop table? I want to check it. So if I run this particular statement, as of now, this is 3. So this is within the 1 minute. There was the delete statement was run. So let's take before 2 minutes, right? So if I run this one, I should be able to see that, okay, before 2 minutes, the state of my table was that I had 4 record into this table, right? But currently I have in the actual table, I only have 3 records, right? So this is happening because Snowflake has stored both the version of the data, right? One where we have the ID 4 and one where we have the ID uh, uh, which does not have ID 4, right? The both version of the data is sitting into Snowflake in the micro partition, and that's why we are able to access this data, right? Now let's say this is with the offset where we are specifying that, okay, 5 minutes before, 10 minutes before, what was the state of my table, right? let's say at a particular timestamp, if I want to check it, right, that okay, at this particular time, before this, at this timestamp, what was my data? Let's say you created your table at 10 a.m., right, and you inserted the data, and then you deleted the data, let's say at 10:05, 10:05, right? So at 10:04, what was the state of my data? That it would have 4 records, but at 10:05, the state was that it is going to only have 3 records, right? So now let's see the current timestamp when the table was created. So I'm going to do show tables here, okay, which is going to give me that okay, when the table was created. So I created this table around 3:20 at 8:29. So I'm going to copy this table, and I'm going to put this at this timestamp where what I'm saying that okay, my table got created at 23:58. Now let's say after few seconds I inserted this data right into the table. So what I'm going to do at let's say at 23:58 at 50 seconds, what was the state of my table? Because at that point of time I had inserted the data into my tables, right? So if I execute this one, I should be able to see that okay, so at this point of time I have not inserted the data. So let's say I do it at the 59, what was the state of this data? Okay, so if I execute this, so I should be able to see at 23:59 the state of my table was that I had 4 record over there. After that I run the delete statement, and that's why currently I don't able to see the data into my table. So at this point at this timestamp I had 4 records into my table. Okay, now the another way that okay, you can see the state of the table before running any particular statement, right? So this is the statement which I have ran where I have deleted the id from my table. Okay, and so I want to see that okay, before running this particular statement, what was the state of my table? How many records I have in that particular table, right? So I need to get this statement id. Okay, so to get that statement id, I have to go into my query history over here. Okay, click on that, and you should be able to see when you ran this delete statement. So this is the latest delete statement what you have run over here, where you are deleting the id is equal to 4. So if you open this one, you should be able to see a query id over here. Okay, so if you copy this query id, come back to your projects under worksheet, you open the worksheet where you are working, and you just need to paste that query id over here. So any SQL statement what you run in Snowflake, it will generate a query id for you. Okay, so if you see the state of the table before this statement, right, you should be able to see those 4 records over here. So let's execute that. Okay, now you should be able to see that you at that point of time you had 4 record into the table, right? Now you want to restore this table, this data into actual table, right? So what you can do is like you can create a clone table uh, of of your drop table based on the select star from the statement. So whatever you had the data before running this drop statement, you are just creating another table which is you are calling as a clone table. So let's execute this one. Okay, so I need to update this particular statement because this was the statement which I have had excuse ran. Update this statement. Now, if you execute this one, it should be able to create your clone table over here. Okay. Now, what you can do is like you can truncate your actual table, truncate table, drop table. Okay. Because you don't want the current data. And then what you can do is you can insert the data from your clone table to your actual table. Okay. So let's insert this data from here to here. So now your data has been inserted 4 records. Now, if you go and select the data from your actual table, drop table, you should be able to see those 4 records, right? So this is how you can restore the data again back from a from a certain point in a time in a history. Okay, and that's why you can recover those mistakes what you have done intentionally or unintentionally by deleting some rows of the tables, right? And then you can go back and drop your clone table because you don't need. So this is how you can use the time travel by using add command or before command in Snowflake to reverse the mistakes what you have done while deleting some data from your table. So this is a one way to do a time travel in Snowflake. Now let's see, there are another mechanism to do a time travel is a simple where you can undrop the statement object what you have created. So let's say somebody comes back and by mistake drop the table or drop the schema or drop a database, right? So how do you instantly restore that data, right? So let's say I'm going, somebody comes back and they drop this drop table by running a command called drop table name. So if I execute that, my drop table is deleted, dropped. Now if I refresh this page and come back under tables, I will not be able to see that drop table over here, right? So now if I also select this, it will throw me an error saying that this table does not exist, right? So by running a simple command called undrop table and the table name, Snowflake will be easily recover that table from the drop state, right? So if you run this statement here, my table is successfully restored, right? If I refresh this particular page, I should be able to see this drop table over here. So this is a very simple way where you can reverse the drop command ran in Snowflake, right? And this could be applicable to a table, view, schema, and database. Let's say you have this schema and somebody comes and drop this schema by mistakenly, right? So if you drop this and refresh this page, you should be not be able to see that particular schema, right? By running this simple command called undrop schema my schema, you should be able to restore that schema again, right? I refresh this, you should be able to see your schema. Similar can be done with the database. Somebody drop a database, so currently you are able to see this database, right? If you drop this database, drop database name, and if you refresh this, you will not be able to see my DB over here, right? Simply come back and undrop this, right? So it will able to restore your DB, right? So if you refresh this, you should be able to see this DB. Okay. Now how do you how this works, right? So as we discussed that it is works because Snowflake has the micro partitions where you can apply a data retention on different objects in Snowflake, right? So let's first set up our database and schema, because this is where we want to run all these queries. So let's set up this one by using the use schema. Now, if you see the databases, schema, and tables inside that, you will see an option of data retention applied on this, right? So if I run show databases, under the MyDB database, if you scroll on the right hand side, the retention is applied as 1 day. This is the default retention what Snowflake give it, right? So up till 1 day, you will be able to perform all these activities of time travel, drop, undrop successfully, right? Similar to that, if you see all the schemas, there will be a default retention applied on that, which is nothing but 1 day over here. And this can be changed, right? As we discussed in the previous sections, right? So you have retention on schema also 1 day, and if you see the tables also, you will have a retention applied on the tables also, right? So if you scroll down, there is a retention of default 1 days applied, right? So within 1 day, you should be able to do all these activities what we have done on the above section, right? Now you can change this retention also. Let's say the current retention of my table, which is the drop table, is set to 1 days. I want to change that to, let's say, 30 days, right? So we have to just run an alter command where we am going to set it the retention from 1 to 30 days. So I'm going to just run this particular command where I set the data retention time in day to 30 days. Execute this. The table is successfully altered, and if I just do a show tables, I should be able to see that for my drop table, the retention is now updated from 1 to 30, and this can go up to 90 days in an enterprise version. Okay, so this is how we set the time travel based on our use case in different tables and schemas or databases, and by using those time travel, we should be able to access the data of that particular tables at given point in history by using the add statement of before statement in Snowflake, and should be able to reverse any mistakes happen into your database while running some DML operations in the tables. Hello and welcome to the Academy. So in this video, we are going to talk about cloning concept in Snowflake. So it is often periodically required to replicate a real-time data from production environment into your dev or staging environment to have an accurate unit test result for the latest changes planned in the project. So let's say you are planning to make some changes into your production code. Before deploying that code in production, you might have to test that changes on an actual production like data. And for that, what you have to do is you might have to replicate the real-time data what is being generated in the production environment to your lower environment such as dev and SIT to test that changes what you're doing it, so that you will be able to cover all the different scenarios uh, with that from that change based on the data of the production. So one of the biggest difficulties in traditional databases is replicating your database object from one environment to another because it involves proper planning, additional storage cost is required, long waiting time for entire process to complete, right? Because you might have to set up a pipeline which is going to read the data from your higher environment such as production and move the data to your lower environment such as dev and test, right? But in terms of Snowflake, Snowflake simplifies this process of replicating your data without incurring any additional storage cost and long waiting time through zero copy cloning, what we call that in Snowflake. So zero copy cloning is a feature which provides a quick and easy way to create a copy of any table, schema, or entire database you can clone without incurring any additional cost, as the derived copy shares the underlying storage of the original object, right? So if you want to quickly take a snapshot of any table, schema, or database, you can use the zero copy cloning. As we said that no additional storage cost will be charged because the clone made from the original, right? Um, it is often used to spin up a dev or test environment for your testing and all that, and it also works in effective way in the backup option also, right? So let's see how the cloning works. Now let's take an example that you have a table called A1 table in your database that has the data of this table is stored into four different micro partitions, which is A, B, C, and D. Okay. Now, if you this is before cloning this particular A1 table. Now, if you clone that table, what happens that you have table A1 and you have table A2 here. Okay. Now, when you clone this A2 table from A1 table, what A2 table is going to do is like it is going to refer to the same micro partitions what your table A1 has. Okay, since both the tables are using the same micro partition, there is no extra storage cost going to associate with while creating the table A2. That means practically your clone is kind of a zero without any charges, like zero copy cloning, right? So you are not going to be charged for additional storage for A2 table until you make some changes into your A2 table. So if you see here, after the post DML operation, if you make any changes into your clone table, what happens that since Snowflake does not update the existing micro partitions, what it does, it creates a new micro partition. So for whatever update you did into the table A2, it will create a different micro partition for that particular update, right? But your actual A1 table, it is still points to the same four micro partitions, right? So until unless you make any changes into your A2 table, which is your clone table, practically both A1 and A2 uses the same storage micro partitions, and that's why it is not going to charge extra for your storage. And how does it work? So this is a simple command through which you can clone any databases, schema, or data tables. So you just write create. Here we are cloning a database. So the statement is create database test DB, clone the production DB. So if you want to clone your current production DB as a test DB to test into lower environment, we can just run this particular statement. So let's see how do we do this into Snowflake. So for that, let's log into your Snowflake account and open a new worksheets if you have. Okay. Similar to other you videos, let's set up the context first. We're going to set up role to account admin, warehouse to compute warehouse, and schema I'm going to set up as my DB my schema. Okay. Once you set up that, let's say this is a current database what you have mydb, which is nothing but your production database, and you want to clone this particular database to create a test database. Okay, where you want to make some sort of update, make the changes in the data and test your code on that particular data set, right? So for that, I'm going to create a test mydb and cloning that mydb. So this is a simple statement what I'm running, create or replace database, the name of the database, and the clone, which database I'm trying to clone. So if you execute this particular statement, what a Snowflake is going to do is it's going to clone the entire database along with all the objects what you have inside the MyDB. So if I refresh this particular page, I should be able to see my new database, the clone database test MyDB created here with the same structure what we have into MyDB. So we have three schema, sorry, and we have three schema here. If you open your my schema and inside the tables, you should be able to see these many tables, and inside your test MyDB also under the my schema, if you open the tables, you should be able to see practically all the tables what you have, right? So now you can do any activity on this particular database without impacting the actual data which is sitting into MyDB. Okay, so this is how you can leverage the zero copy cloning inside Snowflake to spin up of any dev or test database for your testing purpose from your actual production database, uh, uh, removing all the different issues while which we were facing in the previous technologies where you have to have a proper planning, additional storage cost, or long waiting time for entire process to complete. So practically you are avoiding everything which we are doing in the previous tools and technologies by simply cloning those objects in Snowflake.